3 years doing type training on the 330 and 350 subjects. And 2018, I joined CE as an instructor. So over here, I mainly teach on the 320 and the 330, focus on the B1 topics now. So my forte is the airframe systems. If you have anything related to the airframe system or engine, just feel free to ask. If you ask me about B2 subjects, it might be a bit limited. I try to explain with my whatever I know. Okay. So there's only one rule in this training. There's no stupid questions. Some of you are maybe new to this industry, so it's better to ask now rather than later. So no stupid questions. Anything you want to ask, you just ask. Unless the guy Tanya Master in the classroom, you can ask me during break time. That's my WhatsApp number. You can call me also. If I'm free, I'll pick it up. But don't ask me anything outside of the training. Nothing about my personal life. Don't ask me about money. Don't ask me about oil also. Okay? That one is a taboo. So anyway, so the plan is, since you have finished phase 1, I believe you all are pretty familiar with the flow. But phase 2 is a bit shorter. You will see a lot of repetition of the systems. So I will just go through briefly again, and I will pay more attention on the League 1A system differences. Okay, so that will be our main focus. And phase 2 will be shorter. It will take 3 days, actually 2 days. I need to complete the training today and tomorrow. For this notes, I just want to also. And Friday, besides Valentine's Day, guys, prepare your team. Don't forget about the exam Friday. Okay. So focus on exam first, Valentine's Day later. That is more important. Okay, so that's all about myself and the training. I would like to know a little bit about yourself also. So again, I know you have done this multiple times, but most of you guys I have seen you for the first time. So just tell me your name, where is your department, and where you're based in. Or if this is your first job, this is your second job, where was your previous company before? If it's your first job, you just graduated, where was your training school before? Or from other industries here, right? Okay, so that I can gauge how much I need to explain. Alright, that's my view. Morning, you can sit down, just be comfortable.
It's Gavin.
Yeah.
You call me Gavin. From here at school. And first employment.
First employment. Before that, where were you studying? Amala. You're doing P1.1 or P1? That's good. Yes, sir.
My name is Calvin. Based in France. Before this in languages.
Before Harvard? In Asia. Asia. Yes, sir. Before that, where were you studying? For AMAC. AMAC in Johor? So you continue for Mata or you join after the Sorry to hear about that. Mata. I trained some of your seniors before, but that was a long time.
My name is Kai. I'm a technician at the base maintenance. Before this, I was with Malaysia Airlines as a vendor technician, and I'm still doing my B1.
Okay, that's good. Yes. Before that? So it's good, at least you have some exposure on the aviation and stuff. But on the system, actually, to be fair, it's quite tough. It's going to be tough if you haven't touched the aircraft before. Some more it's an Airbus. If you're more on a Boeing or other kind of aircraft, it's a completely different thing. The Airbus is a bit different in design, their philosophy. So anyway, if you want to know more or whatever I explained is unclear, I will try to rephrase it and try to explain to you in a simpler terms. The main idea is to get through your examination. That is more important. Yes.
Hi, my name is Diff.
Yeah.
I'm from Jovie Pension. Previous company, DNB.
Oh, DMB. So totally new to you. Gonna be interesting, but the problem is that the course is too short. Actually not easy. What you are doing is, even though it's a level 1 information, you try to squeeze in everything within 1 week or 1 week plus. The typical type training will take like 2 to 3 months. So it's like half of the information. Okay. Anyway, anything just ask? Yeah, yes, sir, at the back.
My name is Mohammed. SFA.
我識 A 本行單嚟嘅 license，咁normally must 嘅班嘅。
Masuk depan SFA.
Start tulis pada lagi.
Satu di gas masuk depan dengan SFA.
Hi, my name is Android. I'm BNS again. Before this, my PTI Airways.
你看了 for how long?
3 years before COVID.
Oh, you see a match my friend warm.
Kena.
It's good. Good to be back on Malaysia. When are you going to Middle East again?
I don't know yet.
Not opening guys. Good.
My name is Jonathan Agan. I'm from 330 BMS, Purhingga. Previously, I'm working with General Aviation, with Aerospace and Subarmaro.
So I think the system wise is pretty similar, but the thing is Airbus a lot of fly by wire systems. So anything you want to ask, just ask.
Morning, sir.
Yeah.
My name is Mustafa Ali. This is my third. Before this, I working with Western.
West because rotocraft and anyway, anything you want to ask, you just ask. So far the system okay, boleh faham.
Right now, I'm getting store.
Oh, you're in store lah. Because store is a bit unfair to you guys also actually is systems kan. What you know is more like the components, the name of components. So I try my best okay, to let you understand. Anyway, just in case if you fail the exam then will no harm lah. Because as long as your attendance is recorded maybe they will just send you for a recourse lah. And you already know more or less what are the questions will be coming out, so you just keep it first and then campak dalam tong sampah. Because next training you might need it again lah. Okay. Anyway, there's a helpline lah if you need me. Okay, sir. What before that? Okay, yeah. Okay, wrong. Aero ada composing workshop juga lah. Oh, meeting. Now you report to Clinton lah. Clinton lah. Anyway, regarding the system, just ask if you have any questions. I know structure-wise you talk lah, expert lah. Okay, sir. Before that, the spirit is more like manufacturing. That's not money.
My name is Muhammad Rafi. I am from food
Where was your training done?
Hi, good morning. I'm Aditi. I'm from Management for the leadership. And previously working in the SAS service.
Oh, SPS. Last time which aircraft you all operate at SPS? Oh, you're not good lah. So the Embraer tak jadi ya. Better move on lah. Before it's too late lah. You did a good job. Anyways.
Hi, my name is Harusa. They call me Nisa. I'm from Kunai Maintenance for ATP. Previously, my job is in an aviation company. It's electric company.
Like
This is my first company for aviation.
So they put you on the mechanical or avionics side? Mechanical lah. Wait, gonna take some time to pick up lah. But one thing about aviation the starting point, the learning curve is very steep lah. But after a few years, you'll be doing the same thing over and over again. Day after day, it's the same thing. So eventually, you know more than you should lah. Okay? You are working, so no worries lah. But for the first 1 or 2 years, it's gonna be quite tough lah. That's from my experience lah. Yeah, I'm a day, my first 5 years is shit lah. Okay, that one After that, things are going much better. Eventually, still got to wait. You still at the back?
My name is Michelle.
Yeah.
From Ocean India. This is the second.
Before that?
Vendor aviation.
Oh, okay. Thank you. Yes, sir.
Good morning. My name is Ali. Currently at two BMS Aviation. This is my first aviation.
Before that, where was your training school?
Media.
Yeah. That one you did a licensing program or diploma?
Degree program.
Degree program. Okay, right.
My name is Jovie Hakim. From BMS School. This is my second job. Before this, Masgabah at Imam Best.
Bonisa, my name is Faizrin, they call me Faiz. I'm a A320 technician in Rohingya. For this, I work as a vendor technician for Sepang aircraft.
Oh, in the SAE, yeah. SAE pun ambil vendor juga. Oh, okay. Different department. Anyway, anything about anything you want to know more, just ask. Okay, you try. Yeah, yes, sir.
My name is they call me Jovie. Currently in A320 line maintenance department. This is my first job. Before this, I study in Kenya, in my diploma.
Getting B2 lah. Actually, if you can, you go for B2 lah. B2 for the higher demand. Really lack of a B2 lah. But B1 you need more hand count lah. So actually it's good lah, depending on what you want. For me, B2 is okay. And you can also work in aircraft in the future.
Hi, my name is Kevin. From 320 maintenance. This is my first job.
Job before that, where were you studying?
Also from
Yeah, also lah. Doing diploma. Yeah.
My name is Diff. Currently, I'm at A320 to LS. So before this, I also in
Okay, okay. Yes.
My name is Mira. I'm from BMS, and this is my second job. Before this, I work at AT.
Oh, sorry, your technician also. Technician, okay, thank you.
Before this,
Error, see you. Yes.
My name is Putri Iman, I from Iman. This is considered my first job lah. So
Yeah.
before this, technical reports at MRO Subang. And then,
Now you stay under that records, huh?
technician.
Technician, okay, thank you.
morning. My name is Kairon. I'm from the production planning department. So this is my first job. I am also from Indian Cabinet.
Oh, okay, so at least you have aviation background. Right, that's good. Thank you very much. Seems like we have a mixture of experience and a really variety of departments. So if there's anything that catch your interest on your related role that you are doing, like planning, you want to know more about planning stuff, stores, feel free to get some weird tooling, you don't know where is it, maybe you can see some pictures or I can explain to you where does it go. So at least you have some general awareness and more related to your interest. Okay. So without further delay, I will start the training. So far, any questions from phase one? Is there anything that is hard to understand? I think Mr. Jovie did a great job in explaining everything, right? So the layout looks a bit different, but anyway, the information is the same. Okay, so just let me do a recap on 320 family. Any idea when was the first 320 takeoff? 1988, okay. So it was not a new aircraft at all, but almost like close to 40 years, you can think it's going to be 40 years, okay. But compared to 737 even longer, 60 years technology. But at that time, this is considered a very new technology because this is one of the, actually not one of the first, it is the first aircraft on a commercial aircraft that uses a lot of fly-by-wire systems. So previously, fly-by-wire is not a new thing. Back in the military aircraft days, they really start to use it. Okay, but this is the first one that is widely used on a commercial aircraft. So it proved to be quite a success. So on the Airbus family that was developed after 320 or so, uses fly-by-wire. But before that, we have an A300, which is still mechanical. Okay, using flight control vehicles. Okay, what are the family members of the 320? You have covered 320, 321, 322, and then 323. The longest is a 321. Okay. So what are the engine options available? CFM 56, the one that we covered past 5 days. Okay, that one later on, that one is on the Neo series. So this one back in the old days. Originally, you got 3 engine options. Okay. International Aero P2500, which is used by Raya Airways. PW 6000, correct. So PW 6000 only exclusive for 318. So 318 is a rare breed. I haven't seen the 318, let alone the PW 6000. But it can only be treated on the A380. Okay. So if you happen to see it, you can buy it also. Very hard to buy. Okay, so what's next? I think somewhere in 2005, they have updated the system. Just like your car, you cannot sell the same old Proton Saga back in 1980s. You will not buy it. So at least you need to refresh the system or update the system and put in some new tech. So what they have done, they have reduced the number of computer boxes. They have made some minor changes. One very obvious thing is the FAT. Your flight attendant panel. Last time it was on a 2-button type with the digital without any colors. So you got the black color screen with the green color wording and the symbols. Now they have changed it to a touch screen and everything is colored. Okay, so that is one of the major changes. And what they have done also, they reduced the number of computer boxes. Okay, and also inside the cockpit, if you go into the cockpit, you can operate the same way. The buttons are exactly the same. But what they have changed, how many display units do we have inside the cockpit? 6. So the display unit, they change it in from CRT, which is a cathode ray tube, very old school TV, to LCD screen. So those are some of the obvious changes. But for pilots, they don't need to do any retraining. I still consider the same type. Okay, just that they updated the system. The aircraft still behaves the same way. Okay. So what we are covering now is actually called, for the past 1 week, that one is actually enhanced version. So the very, very old version is called Classic. Okay. So if you want to buy after 2005 or so, you may not get the old version, you get a facelifted new version called Enhanced. Okay. So this Classic and Enhanced uses these 3 engine options. Okay. Right. So now the time goes to 2015. So if you still want to sell the same old aircraft like this, you will not buy it. Okay. So what the airlines want is a fuel economy. You want a more modern engine which consumes less fuel. Okay, that is the main idea. Less fuel, less. You can get more revenue. That is the main idea. More money. So this one we call it current engine option. And for these 3 days, we will cover about new engine option. So new engine option, you can buy with 2 engine options available. So the first one is what we will be covering, which is our configuration CFM-1A. Okay. So we also have another option which is PW1100P, which is a geared turbofan aircraft. So the fan is printed by accessory gearbox instead of directly driven by an N1. So a bit different. So your fan can drive at a lower ratio, which is more efficient. So yeah, if you want to sell to airlines, you need to put in some new panel. So on the LEAP-1A, there's also some new technology which I will cover. Okay. So So only 2 engine options available. But unfortunately, what we will cover is only P1A. There's no Dynamite registered PW1100G series yet. Okay, so what we have in Malaysia is only CFM P1A. Very right. And a little bit of extra info. They have dropped 318 neo. There's no 318 neo currently being produced. You only got 319, 320, and 321. The reason being, 318 is very niche. The aircraft is very short. And Airbus, they have another model which can capture for their market, which is Airbus A320, coming from Bombardier C series. They told them it's an Airbus Wing model, and that will cover 318 in the market. Okay, so they have dropped 318. So what we have for Neo series are 319, 320, and 321. Okay, so yeah, they're still valid until today. Right, so what we will cover for these 3 days is one, return with the D1A variant or new aircraft. Okay? So take note, this one is important. There might be possible, you might see it somewhere on Friday. So there's no 318 neo, only 319, 320, 321. Which one is the longest variant? 321, obviously. Okay. So the content is what we have covered on the past 5 days, but again you will see again the same information repeating. In the chapters we have slightly different information because it's more weighted for T1A. Okay, but most of the system, I would say like 90% of it, you just see the same repetition. But unfortunately, the exam will still cover all 88 chapters. So each 88 chapter, maybe you get 1 or 2 questions. Friday. So it's separated into 4 sections. We have introduction, airframe system from 1839 all the way to 38, avionics 31 to 33, power plant. Most of the differences on the power plant, especially on the engine. The topic we will cover on the D1A system. Okay. And something extra is this one, fuel tank igniting system. You might have seen some slides in the fuel tank safety or EVs now. So that one is actually a 320 system. So by default, when you purchase a new aircraft, you will get a fuel tank igniting system. Not that it is regulation. So we will cover on an aircraft general information, which is more or less the same topic that we have covered. So I think you have seen this picture already. The dimensions are still the same. Okay, so from the lowest point of the fuselage to the ground is F. It's around, this one is floor, should be E. Maximum fuselage clearance is around 5 feet, 11 inches. So the lowest point of the fuselage to the ground is roughly 6 feet. Okay, that is the clearance. If the landing gear is properly serviced. Okay. The aircraft is not that high. From the cargo to the ground, it's like 6 feet 9 inches. You will not die if you fall from this height, but you will still get injured pretty badly. So as usual, when you are working on the aircraft, you need to be careful. Especially if you from GD, maybe the aircraft is a bit smaller and lower also. And from this height, this one you can cause serious injury. I think you might have seen some footage before. I think it's from Indonesia 1 or 2 years back. Ground personnel wasn't aware. I think it's from PT Just. So this fall from that height, you will get injured very badly. So whenever you are working on aircraft, always observe the clearance. Okay? Line maintenance, base maintenance, make sure you have a proper docking. Okay? Very vehicle, high available. Okay, so is there any difference? Same man. Forward door, aft door, and 2 overwing doors. No, same. Okay, one small difference is this one. The engine now is much larger. It wasn't reflected accurately in this picture. So the ground clearance was much lower. If you have opened the D1A fan cowl before, you literally have to lie on the floor and open it up because the rear clearance engine doesn't even start. So a bit restricted on the space. And one small difference is what? The winglet. Okay, the winglet looks a bit different. So on the SEAL aircraft, the winglet was sharp. sorry, we don't call it a winglet, I call it more like a wing fence. You can tell the jumping gun. Enjoy that. So what they have done on a new aircraft, by default you will get a much refined, nicer shape, blended wing, which is called it's the same thing as a winglet, but they call this a sharklet. The thing is, with copyright issues, they cannot put the same name, even though it's the same thing. And then this one they call it a wing fence. Okay, so for composite and sheet metal workshop, you need to be careful. Wing fence is aluminium alloy. Okay, so there's sheet metal repair mostly. A bit other stick composite at the back. This sharklet, most of it is composite, which is CFR. Okay. So what they have done is that on the sharklet, if you compare side by side, I think it's 1 or 2 meters longer. And also because of the shape, you can actually make the aircraft less drag to fly. So according to Airbus, what is the benefit? You plus around 100 nautical miles in the range, which is quite a lot. Then you can use the aircraft for longer. Right? So you might have seen some steel aircraft with the sharklet or so. Actually, you can do a modification, but that will require some sheet metal and composite work as well. Okay? So you can modify to this type of a sharklet to make it fly longer. But when you purchase a new aircraft by default, you will get a sharklet like this. Okay? So from afar, you roughly know this one is a new aircraft or a steel aircraft. Okay, any questions here? Good. Okay, so the servicing locations or servicing points do you see any difference It's the same thing like what you have covered up. So just a quick recap. What we have on the forward end, we have an external power receptacle in front of the nose landing gear. Okay, so you got a power GPU. One connection is a narrow body. How many water servicing panel and how many water drain panel? One water servicing panel. Is it on the left or right hand side? On the right hand side is the waste servicing. So this one we call it PWSP, multiple water service panel. How many drain panel for A320? 2. So we got the forward drain, and this one we call it the up drain, or sometimes we just call it the tank drain panel. Because why? Where is the water tank location on the A320? Around here, it's at the up end of the forward cargo. So most of the water will come out from here. Okay. What about A321? How many drain panel? How many remote water drain panel? 1 only, because why? 321 water tank is not here. 321 is actually a cylinder. So your portable water service panel, most of the water will also drain off from there. So by having this design, you will need 1 extra panel. So only 1 portable water service panel and 1 forward drain panel. Okay, for every 21. Right. So you can see some small information here. This one, 320 only, 320 got this up drain panel, we call it tank drain panel. Okay, so remember the panels, what is the total amount of the panels? So for 320, 1 portable water service panel, which is standard, 2 water drain panel for 320. For 321, 1 portable water service panel, how many water drain panel? 1. Okay, that's good. So any other things? Where can you carry out ATU servicing? Can be only one place, you go to the back, that is where you can do APU engine oil servicing. These 3 panels over here is hydraulic servicing panel. Okay, how many hydraulic systems do we have? 3, green, blue, and yellow gas. Okay. So if you want to do hydraulic servicing, which panel do you go to? Green. Okay. If you want to get the handle manually come out, you need to go to yellow one. That's good. So green panel is here, yellow panel is here. This one is the blue hydraulic servicing. Okay. Anything else? So for ground operations, you have an LP connection and an HP connection. This one for aircon, and another one is for TTSU. If you want to do engine starting, you want to supply to the PTS system. On the engine, as usual, you can service engine oil and also IDG servicing. Okay, so these are the 2 things that you normally service. For CFM 56, your engine oil servicing panel is on the left or right hand side? left hand side. So now you need to forget about that. Now it's on your right hand side. C1A is on the right hand side. Okay. So you need to remember until Friday, unfortunately. But on real aircraft, you don't have to remember. You just take out one other voice servicing with your deck out. It's on the right hand side. So number 1 and 2 is on the right hand side. Okay. So I will show you a better picture as we move on to engine systems. If you want to do refuel defueling, you want to read selections, kan? Where is the refuel defuel panel? It's on the right. So it's on the forward end, okay, on 320. So because why it's on the right hand side, we have a refuel defuel coupling on the wing on the right hand side by default. That one is standard. The left hand side is optional, but our aircraft got both sides now. Just in case one couple, you can use the other side to continue refueling. Okay, so a standard airport arrangement is that the 2000 normally kita pakai left or right hand side? Right. Left hand side is for passenger boarding and disembarking. Right hand side is for ground operations. So that's why the location of the refuel defuel balance on the right. You can see what is happening. Okay. Any other things? Okay, on the wing, what else? Okay. There's a weird config also. If you ever on the 737, the refuel defuel panel is just next to the refuel coupling. You can actually make this option on the 320. So you can actually place additional refuel defuel panel next to the refuel defuel coupling. Okay, but this is a rare option. I haven't seen it, but it's possible. So that's why that's the reason. Okay. So also another option is overwing refueling, which is number 10, gravity fueling panel. So if you happen to divert to some airport without any pressure fueling facilities, yang pakai howser, you might need to top up macam vertical just use the gravity fueling. But I have never seen such operation or done it throughout my career. So if you happen to see, maybe you are very lucky. Most of the airport are other ground punya supply. But anyway, you have a cap on top. Maybe on the modern aircraft, they might have just removed the thing altogether. Because like aircraft like 350, no one be using it, so why you want to make one extra? So they might have removed now. So maybe you will not see it on the new aircraft on the later generations. Okay, so we go back to one page before we highlight this part, which is what I had explained. Remember the number of portable water drain panel. Okay, 320 you got 2, 320 101. Any questions so far? Good. Okay, jack tape. Cover this information. Where are the main jack points of this 320? You got 3 right main jack points. So you got 2 outboard of the pylon, okay, below the wing. Another one is on the forward fuselage. Okay. So you need to be careful, especially if you came from the wing. The wing main jack is on the wing and the tail. So never use the tail to check out an Airbus. Most of the Airbus, the main jack is on the forward end. What do you call the tail punya jack point of the light? Safety stay. That one is to support the aircraft. That's all. Okay, you don't carry any weight. So in the hangar, you jack up the wing jack and the forward jack are level to the required height. The safety jack, safety stay, you just load up a little bit just to support the aircraft. Because during base maintenance, especially, you are removing engines, galleys, a lot of things. So the COG might change just to prevent the aircraft from toppling. Okay. So do you need to install adapters on the main jack? Yes. The wing you got adapters. The nose also you got an adapter, but the installation is a bit different. The nose one you just screw it in. The wing one you got 2 bolts, and 2 speakers to the light. So you just put it in, tighten the bolts up, okay, then you check it out. Okay, so what you are checking is the rear spar. This part, this is actually the primary structure. It's attached to the lower side of the rear spar. You are checking up the rear spar of the wing. The forward end actually you are checking up one of the forward frame. It's also a primary structure. So yeah, this is important. Okay, this part, we've got 3 checkpoints. Remember the checkpoint location. The wing and the forward jack is the main jack. How do you check the leveling on the 320? The easiest easiest way is by using Adiru. So you just power up the aircraft, align Adiru, wait until Adiru are fully aligned. Then you go to, how do you access the system? MCDU. So you go to a selection called INSA, Aircraft Integrated Data System. From there you click on PTCH, ROL, you can check what is the pitching and the rolling attitude in digital format. So what you want to achieve is 0.0 or less during checking. Okay. If you don't have Adiru or electrical power available in the hangar, now power down spirit level. So how many spirit level required? 2. Okay, so where do you place the spirit level? Forward cargo or forward cabin up in this refer to the manual. So you just letak satu on the longitudinal plane, one on the lateral. Just make sure the power is in the middle. Okay. So even though it's very straightforward, you should use control punya tooling as usual. Like you go to the crib, you should have a serviceable tag. Even though your phone got a more precise field protractor, unfortunately you cannot use it. You need to follow converting procedures. You can get it from Mr. DIY also. You must have a serviceable tag. Must be registered. Okay. So 2 ways. There's a third option we call attitude monitor, but I don't think you will see it on aircraft anymore. Maybe in a 330 ground handling, you will see the attitude monitor picture. So it looks something like this. Or maybe you're as old as me, maybe you have seen it now. So I remember, I think 8G and 127. So it's actually just a grid inside the liquid and another satu air bubble. So you just check where the air bubble sits in. The air bubble sits in the middle, I think D4, that is the middle position. The aircraft is straight and level. So where you will see this thing is on the refuel defuel panel. You open up refuel defuel panel, it's just next to it. This thing, I think they have removed the whole thing altogether. So nice to know. Okay. On the classic variant, you might be able to see this. But even if you see this, I don't think it's serviceable anymore because the screen can get scratched very easily. If it gets broken, the liquid spills out, you cannot use it anymore. So like this, now you pakai Adiru and this spirit level is more reliable. Okay. So if you are wondering what is this attitude monitor, so 330 ground handling you will have it. So just remember you got 2 ways, Adiru and spirit level. Okay, that is the standard. Okay, one small detail is that you need to be careful. You got both 320 and the 321 when you're feet, especially for 2 creep. The wing jack, this adapter, they're not identical, but 320 and 321 is not interchangeable. But if you are a genius, you can actually force it on the wrong aircraft. On the 320, you pasang 321 punya, 321 you pasang at 320. Even though the hole is a bit misaligned, you can happen to install it. So installing is one part, but to take it out, then involve machine shop and maybe ship and so on. Then you build it out. So I'm not sure you have experienced this before, hopefully you don't know. Okay, but customer fee is there, anything can happen again. So make sure you double check the part number and make sure you double check the part you're working on. If a 321, you should get the correct part number. So an easier way, I'm not sure whether your company practice or not, is that you just paint the A321 or 320 on the adapter itself, at least you will identify to minimize human error. Okay. That's from the manual, actually it's mentioned in the EFM also. Not interchangeable. Okay, that's all on the introduction. So let's move on a little bit on the airframe systems. So I think you have seen this hydraulic systems already. Okay, so we got 3 systems, green, blue, and yellow. So let's do a recap. How many engine-driven pumps on this aircraft? 2. Which color on engine number 1? Green. What about engine number 2? Yellow. Okay. So we start with the green system. Green system, the main pump is for EDP number 1. But if let's say engine number 1 not running, or EDP kaput, the alternate pump is a PTU, power transfer unit. So how do you run the PTU?
Run the electric
The pressurized yellow, normally on ground we just run the electric pump. So this PTU is purely mechanical. Kalau dia boleh sense ada pressure difference between green and yellow of more than 500 psi. The higher pressure side will become a motor, the low pressure side will become a pump. Okay, so now PTU will pressurize the green system to, we will not get 3000 because of the energy loss. So you will get around 2007 to 2800 psi. Okay, that should be okay. So PTU, remember on the 320 is connected to which system?
Green, yellow.
Always green and yellow, so that you need to be very careful. When you touch yellow hydraulic system, you might accidentally pressurize green system. So make sure you isolate the system properly before you start any work on the hydraulic system, especially if both green and yellow system. So this PTU, normally kita pakai yellow to drive green and pressurize green, but actually if you can also use green to pressurize yellow, it works both ways. So in the worst case scenario on the yellow system, if you have lost all sorts of pumps, the last resort you still got the PTU. So if in flight, engine number 1 is still running, the green side will become motor, yellow side will become the pump. Yellow you will still get around 2007, 2008 psi. Okay, so it will both ways up, but on ground normally kita pakai yellow pressurized green system. So for green system only got 2 pumps. Now we move on to blue system. Any EDP on the blue system? No, not on the 320. So what we have is an electric pump, which is the main pump. So the electric pump actually runs throughout the flight. Once you start the first engine, the electric pump will just run automatically until you shut down both engines. So throughout the flight it will be running. So that's why if you have seen in the 320 before, especially in the middle intersection, once the pilot start the first engine, during one engine taxi, just before takeoff, you will hear the electric pump start running all the way. But after a while, your ear get immune to it. Actually, it runs throughout the flight. Okay, so that is the electrical pump. Alright, so until the pilot shut down both engine, when it reach the bay, then the electric pump will stop. But on ground, you can't force it to run up for maintenance, but you got one more button on the maintenance panel. Blue pump override push button that you need to press. Okay. So if electric pump kaput, what is the next option to pressurize blue? Ram air turbine. Okay, so ram air turbine is a smaller pump attached to a variable pitch propeller. As long as you got ram air, the aircraft is flying faster than 100 knots, it will start spinning. But when the aircraft is static on ground, obviously you got no ram air, it will stop. Okay, so less than 100 knots, it will not be that efficient. So it will stop running. Okay. So as long as the turbine is turning, the ram air turbine will is a backup pump. So you will get hydraulic, but I don't think you will get more than 2000 psi. Somewhere around 1500 to 2000. Still sufficient to drive the flight controls in flight. So out of these 3 systems, which system do you think is the most important?
Yellow.
All. Actually all important, okay? That one is the safest answer. But looking at the design of the pumps, which one do you think is more important?
Yellow.
If you lost engine, you lost electrical power, what is the hydraulic system then?
Blue.
Blue, so you just look for ram air turbine. Ram air turbine is your last resort. So on the 320, I would say blue system is the most important. So now you just look for ram air turbine. Okay. So remember ram air turbine connected to which hydraulic? Blue. So later on, we also covered in the A320, you have satu emergency generator, or we call it constant speed motor generator, CSMG, which is using blue system. Because why? In the worst case scenario, you lost engine, you lost electrical power, ram air turbine deployed, you will still get hydraulic. You can convert a little bit of hydraulic pressure into electrical power, just to maintain the most essential system to land the aircraft. Okay. So that's blue system. Any questions? Good. So let's move on to yellow. So yellow got the most pump up. You have an EDP number 2, when engine is running. On ground, you can turn on electric pump. You also got a BTU. Don't forget BTU can also pressurize yellow, but normally kita pakai yellow pressurized green ground. And lastly, we have the 4th pump, a hand pump for cargo load. So cargo load uses which hydraulic system? Yellow. So you can remember for life, all the Airbus 320, 330, 350, so pakai yellow system. Okay, on the cargo load. So you can use electric pump, which is automatically running, but let's say you don't have electrical power, it's your bad day. You need to go use the hand pump, so you yourself become a pump. Get the handle, attach the hand pump and start pumping. Okay. But this hand pump hydraulic can only reach cargo load, flight control is only. Okay, and don't forward and half cargo load. Okay. So obviously we got your three storage tank, which is a reservoir. The largest one is green, followed by yellow. The blue one is the smallest one. The blue one only powers up flight control. Okay, and CSMG. So, the users, okay, the users we need to do a recap. Okay, so all three hydraulic can be used for flight control. The design of Airbus is that if you only left one hydraulic system, you still can move the flight control system in rolling, pitching, and yawing. Okay, so that is the design. Without hydraulic, can you move the flight controls? Unfortunately, no. This one, even though it's fly by wire, your control is done electrically. Ultimately, you will still need at least one hydraulic. Okay, the muscle pressure to move the flight control surfaces. Okay, so that is the design. Is it possible to lose all three hydraulic? Obviously, like Mr. Murphy, but a very rare chance. In the worst case scenario, if you got both engines shut down, at least you still got your ram and turbine point up. That will keep the flight control still working for a while. So that is the design. So for green system, normal extension, retraction of landing gear uses which hydraulic system? Landing gear, extension, retraction uses green. So normal braking uses which system? Green. Okay. And on engine number one, you got a reverser, you got EDT, so reverser is reverser is green. So these are the users. That is why your green reservoir is the largest, because the retraction actuator itself is the largest actuator out of three, and some more you got 4 brakes, so that's why the reservoir is the largest. Okay. So the smallest one is blue, because blue only powers up flight control and CSMG. So CSMG is important, the emergency generator pakai full system, because why? In the worst case scenario, if you ram air turbine deploy, you still can keep some electrical power available. Okay. So I think all these systems are no go lah. Ram air turbine, full electric pump, CSMG kalau kaput, you need to ground the aircraft. Okay. So on the yellow system, the users we have flight control. Which kind of brake system uses yellow system? Alternate braking and also parking brake. They actually share the same hydraulic line on this yellow system. Nose wheel steering on the 320 uses yellow, and number 2 reverser uses yellow. Okay. What is the function of that accumulator? Each system you got one, something like a pineapple or accumulator. Any idea what's the function? Maybe you have done servicing before, you need to charge up with the nitrogen. And inside you have the separator, so you've got the nitrogen on one side, hydraulic on one side. What is the function of the power accumulator?
Store pressure.
This one, we also have a larger accumulator, we call it brake accumulator, but that one got a different function. That one store emergency brake pressure and also to hold the parking brake. This power accumulator is way too small to hold the emergency pressure for the whole hydraulic system. So yeah, this one is for pressure changes. Okay? It's mainly for pressure fluctuations. So the logic is like this. Every time you turn on and off a pump or a system uses hydraulic and suddenly you don't use it anymore, just like in the toilet, the bleeder, you start spraying water, the whole circuit shaking and because of the pressure change. Okay? So imagine if you have a lot of vibration on the hydraulic lines, what can happen? You will have a leak. Okay? Hydraulic line will be shaping with the clamps, with the adjacent system, and maybe the joints will get loosened up. So if you might develop into a leak. So if you have a leak, you might lose the whole hydraulic system. So what Airbus done, they have put in the accumulators. Okay? So the accumulator, you got one side pressurized nitrogen. They will absorb the pressure change to reduce the vibration and also reduce the hydraulic leak. That is the main idea. Okay. So back to basics. I think most of the aircraft will have that. Even on a Boeing or so, you can have that. GA aircraft should have that as well. Okay, power accumulators. Okay, so let's see what are the important things. EDT 1 and 2, remember the hydraulic. Number 1 is green, number 2 is yellow system, which you know already. BTU connected to which hydraulic system?
Green and
Green and yellow. Okay. Make sure you highlight that. Yeah, one thing is a fire shut-off valve connected to which type of valves? Okay, if you have engine fire, what do you have to do?
Isolate.
Run away. Before you run away, you should safety the system first up. Okay, so the standard SOP is that you shut down the engine. If your thrust lever not idle, return back to idle, shut down engine. You release the fire switch on Airbus. So when you release fire switch, what will happen? You will cut off 4 systems to prevent fire from spreading. So what you will do, you will cut off hydraulic, fuel, electrical power, and pneumatic. Okay? So on the hydraulic part, let's say you release fire switch number 1, the fire shuttle valve will go to close. So hydraulic fluid will not continue feeding the engine which is on fire. Okay, so where can you find a fire shuttle valve? It's just this one is upstream before EDP, we call it upstream of EDP. Okay, so you got 2 fire shuttle valve, number 1 and 2. So you can only control using the fire switch. Okay. So yeah, this part is important. Fire shuttle valve to the engine driven pumps only, not electric pump. So for blue system, what is the main pump? So obviously it's an electric pump. Okay, there's no EDP. 320. Rack end turbine connected to blue system. Okay, so one special precaution is that the rack end turbine you can deploy in flight or on ground. Okay, you just press the rack end button, deployment button, which is a red guarded switch. It will get deployed. But to retract it, you can only do it from the blue hydraulic servicing panel. So it means that you can only retract it on ground following a maintenance section. Okay. So in flight, there's the one-way ticket without deploy, you can't stow it. Okay. You can only stow it back or retract it on ground. Okay. So this part. So to summarize this, SEAL and NEO aircraft are exactly the same system. Usually got no difference. What I've done is just recap. Okay, on the important information. Okay, any questions so far? Okay, so let's go for a morning break. And we have a 20 minutes break. I see you at 10:25. Is that okay? Okay, thank everyone. Let's continue with the training. So far, any questions on the topics that we have covered in the morning? Good. Okay, so let's move on to landing gear in the next aircraft system. So again, between SEAL and NEO aircraft, actually there's no difference at all. Okay, so it's more like a recap of what we have covered. Okay, so for landing gear, you can select up and down. There's only lever in the cockpit. The one is for normal extension and retraction. Which computer is in charge of the normal extension and retraction? DCIU, landing gear control interface unit, 1 and 2 lah. So one is active, another one is on standby. Okay, any idea when will this switch over? Whenever you cycle to up, that is when it will switch over. Okay, and that is important. Another part, with any up selection, LDCIU in command will change and control a complete gear cycle. So it goes something like this. Behind the landing gear control lever module, there's no mechanical cable, only one electrical plug. So it's purely fly by wire, you select up and down. So once you have made the selection, the electrical signal will go to the computer, and then the computer will just control the door selector valve and gear selector valve electrically, but ultimately you will still need hydraulic to operate the gears for normal extension retraction. So the command, like the door open, door close, and gear extend, gear retract, the command signal is coming from computer, but you will still need green hydraulic system to operate it, just like what we have covered. Okay? So normally the logic is like this, when aircraft is on ground, what is the default position of the gear and the doors? The gear should be down, and what about the doors? It should be closed. So once aircraft took off already, now you select the lever from down to up, right? To retract the gears. So when you select to up, let's say LDCIU 1 was active before, now it will switch up. LDCIU 2 will be in command. Okay, when you select to up. So LDCIU 2, what you would command is that the first thing, the door will open up first, the gear goes up, and the door goes back. Okay, so before landing, the pilot select to down again, the door open, gear down, the door goes up again. Okay, so on the next takeoff, when pilot select to up again, so LDCIU 2 will switch back to LDCIU 1. Okay, so that is the logic. So it follows your LDCIU, it follows the landing gear selection. You select up, LDCIU are going to switch over. Or if there is a fault, because LDCIU 1 and 2 always talk to each other, communicate, there's a cross-talking or communication, In case one of it got a major fault, the healthier one will just immediately take over. Okay, so for redundancy. So besides the charging of the normal extension retraction, LDCIU also monitors the position of the gears and doors to give an air ground signal. Okay, so the air ground signal is actually coming from LDCIU Airbus. Okay. So when aircraft is flying at high speed, remember it's somewhere 260 knots and above, 240 or 260 knots and above. In flight, the gears are retracted and the doors is closed. What happens if you accidentally extend the gear at high speed? What can happen? Will there be anything happen or actually no issue at all if you extend the gear at high speed? But why we need to retract the gear in the first place? To reduce drag, okay, so that the aircraft can consume less fuel, it can fly at a higher speed at higher altitude. Okay, so that is the main idea. So on a commercial aircraft, I have never seen any gears which cannot be retracted, except pre-noctal are only retracted because flying at a much lower speed. But when you're flying approaching to, this one is like subsonic, almost go to sonic speed already, almost like a Mach 1 speed. So you cannot extend gear at this speed. If you extend gear at a very high speed, you can cause too much drag, you can damage the gear. The gear is attached to the wing. The wing can also get damaged and the aircraft can crash. Okay? So to prevent any accidental extension, there is one safety law, we call it the safety bar. When the aircraft speed is faster than 240 or 260 knots, automatically it will close. So if the pilot forgot, pilot just moves the landing gear down. Even if there is a command, there's no hydraulic to operate the landing gear. Okay, so the landing gear will remain retracted. Okay, for safety. So this one just following RDU and airspeed. Okay, for safety. Okay, so if let's say during landing, you select landing gear down. The landing gear still stuck in up position. What do you have to do next? Okay. No need to be panicked first, because remember when we LDCIU cycle over, you select up again, then select to down. So pilot will try 2 times up. Once you do 2 times, landing gear still stuck in up position. So yeah, before you start praying, there's one more thing that you can do. Okay, this one, landing gear extension handle. So you can use gravity extension. Okay. So where is this handle? Center for handle on the up end. So how to operate it? You just lift up the handle, you follow the arrow in the clockwise direction, you just turn something like a fishing rod, 3 turns until you cannot turn anymore. So when you are turning, what happens is that the landing gear and the doors will open in sequence. The door unlock will be released mechanically because it's purely mechanical system. So you got a set of control cables from the cockpit all the way to the gear. Okay. So it will release the door unlock. The door unlock will fall by gravity, followed by the gear unlock. Once it releases, the gear will come down. If the door is not fully open, the weight of the door will just push the door to full open up. So the main landing gear and those landing gear got a very similar design. Okay. So yeah, at least you still got your gears down and top up. You can land the aircraft up. And that is important, right? For gravity extension. Okay, so all of the aircraft will have a gravity extension, including like a Boeing 737. What happened on the D2 Air, that one is a totally different thing. On Boeing, I think you have like 3 separate levers, which will do a similar job. But it's hiding at a different area on the floor. Okay, so yeah, 2 things is important here. Landing gear, LDCIU will switch over following the up cycle. Sorry, up selection. The next thing is the free fall extension. It's done mechanically, it's a purely mechanical system. Even without electrical power, you can just How do you know that? So you have a gravity extension, but there's no gravity like alternate retraction system. Is it required to have an alternate retraction? No. No, right? The main idea is to extend the gear so that you can land at point efficiency. So you only get a gravity extension. So without hydraulic to be careful, you incorporate the extension handle, the gear will just come down. How do you know that the aircraft landed with gravity extension? Is there any difference on the configuration of the door and the gear? The gear definitely will be down. Okay? What about the doors? The door door will be left in open because there's no hydraulic to retract it. So if you see one aircraft land with the doors open, means that the pilot activated the gravity extension. Okay, and you need to do extra inspection because the door might get touched to the the runway. It might get some damage. Right? Okay. That's all in this brief hydraulic system. So without hydraulic, no problem. The backup is that you can extend using gravity extension. Okay, it's an independent system. Okay, I think you have covered brake system also, right? So, brake system, we got three modes of braking. Just a recap. So no difference between seal and neo. So the first mode we call it normal braking. The second mode is called alternate braking. And the last mode is called parking brake. So all of the Airbus we have the three modes now. Okay, so on 320 it's quite advanced. The brake actually doesn't have a mechanical cable. It's all a brake by wire system. So coming out from the brake pedal assembly, there's only electrical connections. Okay, so this electrical connection. So we all start with the normal braking first. Normal braking we focus on this half, so on the left hand side. So for you to have a normal braking, you need to fulfill three conditions. Which hydraulic required? System. Which computer required? BSCU. So BSCU brake and steering control unit is the controller. Without BSCU, you will not get into normal braking. Okay. And another one is your anti-skid and no-spin steering switch. Must be in on position. Okay. So if you fulfill this three conditions, you will get normal braking. So for normal braking, you don't have to worry. You always have anti-skid protection available. So pilot just have to slam the brake. If he or she want to do a manual braking, you will get full protection. So if the wheel is decelerating too fast, it will release the brake pressure, it will speed back down. Something like your car being an ABS, not similar concept. Okay, so it will apply and release in the brake suspension to minimize the chance of speeding. Okay, and the wheel lock up. Right. So yeah, BSCU is in charge. So that is manual braking. You also have an auto brake available. So anti-skid definitely will be there as long as your BSCU is in charge. That is one of the functions. You go to the anti-skid protection. Auto braking is available when BSCU is working and normal brake is available. So I think you have covered this also at auto brake. Auto brake, you got how many selections? 3, low, medium, and max, right? So that is the braking rate. So if you select low, the distance will be the longest. If you want to brake, have a stronger rear auto brake selection, you select the medium, you will brake at a shorter distance. The maximum is the shortest, but we don't use it during landing. That one is for takeoff only. Before takeoff, you need to set the maximum. In case other rejected takeoff, you don't want to overshoot the runway. But when you put to maximum, there is a chance that the brake can get too heated up. You can get a brake fire, and yeah, the tire might skid, but the main idea is just to get the aircraft stopped before it's too late. Okay, so maximum only before takeoff. So that's why between low, medium, and max, there's a small gap over there, which I don't think will make much difference. Just to tell the pilot maximum is only used during takeoff. Okay, so during landing, we use low or medium. So once you set the auto brake, you don't have to press on the brake pedal. When the aircraft lands, it touches the runway. So the sequence is normally like this. So when the aircraft touches the runway, pilot will deploy reverser, correct? So when the reverser deployed, the next thing that will operate is your ground spoilers. The ground spoilers automatically will go to full out position to dump any remaining leaf on the wings. The next sequence that will happen is that, depending on what you have select on the auto brake, the brake will just come on automatically. Okay? So what is the pilot's job?
Monitor.
Only takeoff need to control manually and taxi back to 50. But besides that, actually a lot of things. In case of any abnormal gear situation, there's a lot of things that for them to do. Most of the things on the Airbus are automated throughout the flight to reduce the pilot workload, so they can focus on more important tasks. Okay. So yeah, that's all about normal braking. So you can have an auto brake, you can do it manually with the full anti-skid protection. aircraft go into the backup, which is alternate braking. So there are two situations. You can get alternate braking with anti-skid protection or without anti-skid. Okay, so if let's say you lost green hydraulic system, you have a total loss of green hydraulic system. Your BSU got no issue, electrically it's fine. Okay, so as long as you lost one of the condition, either you lost green BSU or this anti-skid no switch steering switch is selected off, it will go into alternate braking. If you only lost hydraulic system, you will go into alternate braking with anti-skid. Because why? Your BSU is still working. BSU still got anti-skid protection. Okay. So what happened is that during alternate braking, auto brake will not be available. Okay. So you need to press on the brake pedal. So you can still slam on the brake pedal. The hydraulic will just go through. But let's say the wheel is spinning up. Sorry, it's spinning down too fast. That is monitored by the wheel speed tachometer. This anti-skid calculation, it will tell the computer of the alternate braking, which is alternate braking control unit, ABCU, to release pressure on your alternate direct drive valve. Okay, so this is the control valve of your alternate braking. So you will still get anti-skid protection, but a bit less precise because we got 1, 2, 3, 4 brakes. Normal system you got 4 servo valve, whereas for alternate braking is controlled in pairs. 1 and 2 controlled by a single valve, 3 and 4 controlled by the other valve. So let's say number 1 under skidding punya situation, it will just release 1 and 2 together. Right? At least you still get the job done. Okay. So that is the first mode, alternate braking without anti-skid. Sorry, with anti-skid. So which hydraulic system they are using? Yellow. So alternate braking uses yellow. We've got BSCU available, but the main computer is still ABCU. Alternate braking is still fly by wire, but done by a more simple computer with more ABCU. Okay. And obviously, anti-skid and no switch steering switch must be in on position. Okay, so that is the first scenario. So the next scenario, if you have a total loss of your BSCU, so you have a major electrical failure of BSCU just kaput, or if you put the anti-skid and no switch steering switch to off, you will kill off the BSCU. So when you don't have BSCU, do you still have any anti-skid calculation? No. So automatically you will get into alternate braking without anti-skid. Okay. So you still need to use a yellow hydraulic system, but now there's no BSCU. Okay. You're using ABCU only. So now you need to be very careful. Okay. You shouldn't press too much on the brake. So if you apply too much brake pressure, there's no anti-skid protection. There is a chance that the wheel can lock up and cause skidding and the tires can explode. So how does pilot minimize this? Is by monitoring the triple pressure indicator. Okay, so it shows you yellow hydraulic system on the alternate and parking brake. The top one shows you the brake accumulator pressure remaining. Okay, so this one is your emergency pressure. This one tells you your left hand group punya alternate brake pressure, right hand group punya alternate brake pressure. So this one and 2, 3 and 4. Okay. So pilot need to be very gentle. You need to press on the brakes. So what pilot will do, you need to pump the brakes until the aircraft comes into a stop. And while you are pumping the brakes, make sure the pressure doesn't exceed more than 1,000. And if you press too much, there is a chance that skidding and the tire burst will happen, and you might get stuck on the road. Okay. So alternate braking, it comes from yellow supply. If let's say you lost the normal yellow supply, we still got the emergency accumulator. So the operation is a bit different from the power accumulator that we covered from hydraulic. This one can store emergency pressure and it's really huge. Okay. So if I remember correctly, you can have emergency braking of up to 7 full cycles. You can press fully 7 cycles. Okay. And if the brake accumulator is fully charged, that can also hold the brake pressure for 12 hours. But after 12 hours, the aircraft might start moving. That's why when I stop, you need to choke the aircraft. Okay. So that's alternate braking. Any questions? So lastly, we have a parking brake system. So parking brake system, no computer involved. You just need yellow hydraulic to be available. So how do you operate parking brake? It's a park brake selector. So it was a pretty new tech at the time, but nowadays even 9B got this EPB, electronic parking brake is the same thing. So it's operating electrically. So when you set the parking brake on, as long as you have electrical power, the park brake control valve opens, full hydraulic pressure will just go to the brake. Okay. So the parking brake control valve only two positions, on and off setting. So, but you need to be careful if your parking brake selector is selected. PSU and ABCU will just disable normal braking and alternate braking because parking brake are the highest priority. Okay. You need to have anti-skid protection for parking brake. Nowhere. You just want to prevent the aircraft from moving it. Okay. So yeah, there's no anti-skid protection. So full pressure of around 2,500 plus close to the brake system. Okay. So it's supplied by wire system means that you will need electrical power. If you don't power up the aircraft, but your battery is still connected up, you set parking brake. Do you know that the parking brake is supplied in the cockpit? Cockpit is totally dark. Externally, you will also have a parking brake light on your nose wheel steering electrical disconnect unit, but that light is also not working. So how do you make sure the parking brake is set? You go to the brake unit itself, you can see half of the piston will be extended. Okay, but do not go and touch it. You see it extended, you got a shiny portion, means that the parking brake has been applied. Okay. So, but the catch is you must have at least battery power available. Okay, so you, some systems are using battery power in the background, using hot battery bus. Hot battery bus, even without any indication in cockpit, it will still operate. So parking brake is one of them. Okay, so some other system that uses hot battery bus is your clock. Even the clock doesn't have any digital display, you still continue to count at the back because that's from battery. Have you been involved with a long-term parking aircraft? Yes or no? You might have been doing. Sometimes when you park the aircraft for too long or inside the hangar, what do you do to the battery? You need to disconnect the battery. So now after you disconnect the battery, you operate this park brake lever. Will there be any electrical power to operate it? No. So be careful. Before you tow an aircraft after long-term parking, make sure at least you connect the battery and charge up the yellow hydraulic system. Okay? If not, operate, nothing will happen. If the tow bar shear, the aircraft will continue moving. Okay, so be very careful. Anyway, let's move back. There are some important information that we highlight. So for normal braking, it's done by BSCU. Okay, anti-skid calculation, remember it's done by BSCU. Okay. So let's say the aircraft goes into alternate braking with the anti-skid protection. The calculation and command comes from the BSCU, but ABCU will just follow orders. Okay. Okay, alternate brake system, you got a yellow hydraulic system, you also got a brake accumulator, which is shared with the parking brake system. This part is important. So with the alternate braking with anti-skid, BSCU is the one doing calculation, ABCU will follow the order. So you need to read the question very carefully. Okay. The order is coming from BSCU, but you will still need ABCU to operate the valves. Okay, triple pressure indicator showing you green or yellow like that system. Yellow only. Okay. Why does a normal braking got a triple pressure indicator? Is it required? Normal braking always have an anti-skid, so you don't have to care, just slam on the brakes. Any problem, you reverse to alternate braking. That is when you need to monitor the triple pressure indicator. Okay. Yeah, so triple pressure indicator shows you alternate parking brake pressure, which is yellow. Why do you have two separate gauges? How come one on the left, one on the right? How do you operate brakes on aircraft? You got the pedal, right? You press up and down, that one is operating the brakes. You kick forward you are operating the rudder and the nose-wheel steering system. Okay, so depending on operation. So normally, how do you apply the brakes? Just press down left. Can you just press on the left or press on the right?
No.
Actually, you can do differential braking, but just that you normally don't do it like this. So when you press on the left, this pressure will go up. 1 and 2 brake will be applied under on the left. If you press on the right, only the number 3 and 4 brakes will be operated. You can actually do that. Okay. So that's why you got 2 gauges, one on the left, one on the right. Okay. No exam pressure now, nice to know. Then let's move on to steering. Okay, so steering is still done by VSCU. VSCU, half of the job control normal braking, anti-skid and auto brake. The other half of the job they control steering. So the steering is also applied by wire systems, really advanced one. Okay, so how do we give orders for steering? How do we control steering in the cockpit? There are 2 things that you can see. One is the steering pillar or steering handle. You got one on the captain's side, one on the pilot's side. So that one gives you a full deflection. Okay. You also have a limited steering control using the rudder pedals. So during takeoff and landing, if the pilot wants to keep straight on the runway, just click on the rudder pedals. As you are controlling your weight, you also have a limited steering to keep it straight. Okay, but I think it's only like a 6 degrees up at the front. Okay, so this part, the input you can do it from the rudder pedals, but it's limited 6 degrees left and right. Okay. So you cannot taxi the aircraft using a sharp corner, using the rudder pedals that we normal. Okay, you need to use a hand wheel. Okay, during taxi. So hand wheel gives you a full deflection, 74 degrees left and right. Okay. So from the hand wheel and the pedals, the electrical signal will go to brake and steering control unit, BSU. And then BSU will just control the hydraulic system electrically, but ultimately you will still need hydraulic to operate the system. Okay, without hydraulic, you will lose your steering. So which hydraulic is involved with the steering? Yellow. Okay. But Airbus, you will notice that there's a lot of logic, like we think about logic. So you need to fulfill certain logic, then only steering will start moving. So for safety. Okay, so this logic are covered here. First thing, your anti-skid and nose-wheel steering obviously must be on. You select to off, BSC will not be working anymore. You will lose normal braking plus steering. Okay, you will kill off the operation. So stay in on position. Aircraft obviously must be on ground. So LDCIU tells the system, aircraft on ground. Now you can operate the steering. Do you need to operate steering in flight? No. Only right. Somehow you cannot operate like it's inside the wheel well. You shouldn't be turning. You should stay at the center position. One engine running. So this is special for Airbus. If none of the engines are running and you have yellow hydraulic system available, you go and move the steering pillar, but you shouldn't try this. By right, the steering shouldn't be moving. Okay, only when you start the first engine, now steering will come alive. But as safety precaution, regardless your engine running or not, you still need to put in the bypass speed. Okay. So aircraft speed also got some involvement with the steering. When aircraft is the ground speed is less than 100 knots, your steering will start to be available. Okay. And also, your steering angle will be limited. If your aircraft is moving faster, it will limit the movement. Only when the aircraft is going slower and slower, now you can get to maximum 74 degrees. Okay, just like your car, at high speed, you turn a little bit, actually you can steer along. Okay, so this one is to prevent over control over steering. So BSU will do this. Towing lever must be in normal position. So how do you put it into bypass position? There's a macam locking spring and you just release from here, you just keep it in straight, but when you release it will spring loaded back to normal. So you keep it in straight position, put in the bypass speed. Okay. So this one we call it nose-wheel steering disconnect box. There's no mechanical cable, only one electrical plug at the back. So what it does, it gives an electrical signal to BSCU to tell the system that you are towing the aircraft, you should deactivate the nose-wheel steering. So it's very important that you put it in the bypass position. Okay, so it's not a mechanical deactivation, it's electrical deactivation. So since you are using electrical, if you tow the aircraft without power, will your steering come alive?
No.
Never come alive, but the manual still asks you to put in the bypass pin for safety. Just remember, even though we know that without electrical power your steering will never work, but you still have to put in the bypass pin every time, okay, for safety. Even with your battery disconnected, obviously nothing will work, but you will still have to put in the bypass pin. Okay, so just make it a habit. Why is there autopilot? This aircraft can auto steer to the gate on Tesla. Autonomous driving. Pilot has to control manually. So this autopilot is there during auto land operation. During auto land, to keep it straight on the runway, your rudder will deflect automatically. It will also deflect left and right 60 degrees. That is the only time autopilot will get involved. Okay? Just to keep it straight on the runway during landing. That's all. Okay. Anyway, a lot of information, but what is important is input. Limited input done by the pedal, 6 degrees. Maximum steering input is done by hand wheels. Okay. Okay, next system is flight controls. So again, QCO and new actually no difference on the flight control. Okay. Computers remains the same, and the flight control surfaces has no difference. The main difference is more like between the model, between 320 and 321. One small difference is the flap design. The flap looks a bit different on the 321. Have you covered that? So only the 321 got the double spotted flap. So I'll show you this as well. I think it's not mentioned here, but anyway, this part first, I will explain it. The difference is 321 have a double spotted flap. So on the 320, your inboard and outboard flap are just one piece only now. Whereas on the 321, the flap design is double spotted. When the flap is retracted, it's like this. When the flap extends, it is equal flap track, it will just come down, and you have a single stop. Okay. On the A321, also got the back surface. So when it's retracted, you won't get any stop. This one is closed. But when the flap extends, the flap will also come down like this. So now you've got two air slots. So it's a double slotted flap. Only on the 321. Okay. This was not the original design, it was an afterthought, because after test flight on the 321, they found out that the aircraft wasn't as stable. The fuselage now is much longer, the aerodynamics is a bit different. So during low speed operation, they found out using the single slotted flap, the aircraft a lot of turbulence. Okay, so what they have done, they have changed, made some mechanical changes on the flap design. So they introduced a double slotted flap, which is more stable at low speed. Okay, so on the 321, regardless of the SEO or new aircraft, the flap will reach much further downwards now. And now it's a double slotted flap. Okay, so highlight this part as well. 321 got a double slotted flap, both inboard and outboard. Okay, so let's do back a recap. How do we control rolling on the aircraft? Rolling means the wing up and down. So how do you control the wing up and down? Yeah, you use aileron. Okay, so if you want the wing to come down, aileron will stop up. If you want the wing to go up, aileron will come down. Okay. So besides aileron, spoilers are also involved. Okay, spoiler. Do you know how to number the spoilers? You got 5 spoilers per wing, right? Which one is number 1? Inboard to outboard. So for Airbus, it's always inboard to outboard. It's number 1 left, number 1 right, and most outboard one is always this spoiler will also be deflected up a little bit to assist the aileron. Okay, so how we can have this kind of complicated movement because it's just controlled by fly-by-wire. The computer just tell me what to do. As long as you got hydraulic, you will just move to the selected position. That's all. Okay. So for rolling, it's done by aileron plus spoiler 2, 3, 4, 5, 2 to 5. So the spoiler's got multiple functions now. On ground, once it's touched down, you will go to full up to spoil any remaining leaf. So it can act as a ground spoiler. It can also act as a speed brake to reduce the speed in flight. So speed brake normally is 2, 3, 4. So you will also go up like maximum halfway to increase more drag to reduce the speed, and also for emergency descent. If you want to descend the aircraft faster, that is how you spoil the leaf, so the aircraft can come down faster. Okay. Anyway, for rolling, it's done by aileron and spoilers. How do you control pitching? The nose up and down. Elevator, and we also have a DHS, trimmable horizontal stabilizer. So the elevator is for short-term pitching movement. So initially, elevator will move first, then the DHS will slowly follow up, so that your elevator can go back to neutral. So you can always have a maximum up and down control. Okay, but it only happens in flight. Okay, so the DHS will move automatically. We call it auto-trim system. Okay. How do you control your wing, the nose left and right? Rudder, we only got a single piece of the rudder. So the rudder is a bit different on 320 in the sense that it's a conventional rudder using mechanical cable, but it also have autopilot manual control. Okay, so normally it's done by autopilot. In case autopilot fails, now you go to mechanical. Okay, it can revert back to a traditional system. Anything else? High lift devices, we have slat and flap. So high lift devices, by the name, you know that it increases lift when the aircraft is moving slower. So during takeoff and landing, you can extend the slat and flap with more lift so that the aircraft can take off and land safely. So again, slat and flap is also fly-by-wire. There's no mechanical connection all the way from the cockpit. Where are the mechanical backups on the flight control? Only got two areas. One is on the rudder, the other one is on the DHS. So we will cover that. Right, so for now, rolling is done by aileron plus spoilers. 3, 2, 1 got the double spotted flap. I think you have covered this picture also, right? Fly-by-wire. What is the benefit of a fly-by-wire system? So we go back to a traditional system, not conventional pakai cable like a one thing missing on the Airbus cockpit is that your control wheels and control column one is missing. So by moving the control wheels and control column, you got mechanical cable, you also got something like the mechanical drum, quadrants, all the mechanical blocks. So mechanical control going all the way to your actuator. So on Airbus, we call it servo, this is the actuator. The command input is given mechanically. Okay. So when the servo valve moving to left or right hand side, it can port hydraulic to either side of the chamber, beside the actuator. But you will still need hydraulic to operate it. But the input is done mechanically. So once it has reached the selected position, it will give back a feedback to neutralize the command. So it will stay in the last selection. So that is a mechanical control. You can see what is happening. Okay. On the fly-by-wire, when you move the side stick, below the side stick only one electrical plug. So the movement changes to electrical signal. Electrical signal goes to flight control computer. You still continue electrically. So this servo valve, instead of mechanical control, is controlled by using electrical signal. You still can achieve the same thing. So you go bias to left or right hand side. You go port hydraulic to extension or retraction of the actuator to move the flight control surfaces. So once you reach the selected position, you also got a position transducer that tell the computer, hey, you have reached the selected position, you will stay there. So actually the operation wise is similar, just that you have changed the control part and calculation part into computers and electrical wiring. So which one do you think is the better system? Better don't debate on this, you will spark a war. So it's between Boeing and Airbus. To me, I need to We start with the fly-by-wire system. So which system do you think is less complicated? See this one here? Okay, so you remove all the mechanical components. You don't have to do flight control rigging, you don't have to do cable loop anymore. Now all replaced by electrical wiring. So you reduce the weight of the component, the system becomes more simplified. So what you have is a control side stick assembly, a computer, and actuator. The rest you just connect with electrical wiring. That's all. So it's much less complicated and it's cleaner. Okay. And you can do a lot of complicated controls because now it's done by computer. As long as the computer do the calculation, it can control the servo. They can control each flight control surfaces differently. So it also reduces the complexity of the system. So if you ever work on the 737, the spoilers, you got the speed brake, you also got the ground spoilers. You also can use it to assist in rolling. Okay, but everything is somehow mechanically. So you got a mechanical spoiler differential unit, which is quite troublesome to do rigging and troubleshooting. So you eliminate all these things because the computer tells the actuator what to do, you move to the position, that's all. Okay. But what is, not everything is good, right? What is the bad thing about this system? Can you see the defect very clearly? No. On a mechanical system, you can check mechanically where is the problem coming from. So let's say you got an intermittent problem, it can be coming from the computer, it can be coming from the computer connector, it can be coming from the wiring. So now we too got a lot of job to do. You need to find out where is the shortage or this open circuit coming from. Okay. So for troubleshooting, it's a bit more tedious. Okay. Sometimes you might not be able to solve it 100%. It's more like an intermittent fault, which eventually will lead to accident like an Indonesia Air Asia because they just keep resetting the CD without solving the problem. Okay. So anyway, that is the pros and cons. But Airbus, they always go into fly-by-wire. But to me, as a mechanical guy, I would prefer fly-by-wire because you don't have to do flight control rigging anymore. You don't have to do cable loop. You don't have to replace cables. If you want to do rigging, you call your P2 friend because the rigging is done on the position transducer, on the actuator. The only part you still have to rig is the rod end linear dimension, and I think that's all. Rod end linear dimension. Make sure mechanically it's straight. Yeah. Let's move on. Okay, so back to the computers. What are the computers available? You got 2 elect, elevator and aileron computer, and spoiler elevator computer. So the fly-by-wire system on 320 is still pretty old school. So the arrangement is a bit different. So now most of the modern Airbus, one computer can control everything. They still split it into separate systems in some ways. So what can ELAC control is that ELAC is more powerful. It can do all the normal law, alternate law, and direct law calculation. And mainly it controls elevator, which is pitching, PHS and your elevator, and also rolling, it controls aileron. Okay. Spoiler is done by SEC. How many spoiler elevator computers do we have? 3, yeah. So in normal mode, when your ELAC moves the PHS, elevator, and aileron, it will also deflect some groups of the spoiler. So this SEC will just follow orders from the ELAC to move the spoilers only. Okay. And what happens to the rudder? The rudder will also move automatically, but that is controlled by FAC, Flight Commutation Computer, only involved with the rudder autopilot operation. Okay. So in normal flight, if the pilot wants to fly manually, you move on the side stick. So how do you control rolling? Obviously, you move the side stick to the left, and the aircraft will start rolling. And pilot don't even have to touch on the rudder pedals. Okay, so we go back to a conventional aircraft. If you're using a mechanical system, if you want to roll the aircraft, you move the control wheel to the left, right. Okay, and at the same time, you also need to kick on the rudder so that you have a very nice coordinated turn. If not, you might experience something like an understeer or oversteer. To have a very nice coordinated turn, you need to couple together with the rudder operation. Airbus, you don't have to do that. The rudder will move automatically. elect the FAC how to move the rudder. So the only time pilot have to use the rudder pedals either you use the mechanical in your backup or during crosswind landing. During the final movement, you press the rudder onto the opposite side just to counter the crosswind landing. So that is the only time, two situations only pilot will need to move the rudder. Okay, so everything is automatic. So that is a normal mode. If let's say you lost elect 1 and 2, now you will go into backup mode. So you still can control using fly-by-wire. So backup mode, you will lose autopilot. You need to control manually. The spoiler elevator computer now can control spoiler and elevator. So you can you still roll the aircraft by controlling the spoilers? Yes, sir. Okay, because what you want to achieve is a differential lift on the wings. Now you still can roll the aircraft. So spoiler alone can actually roll the aircraft. No issue. So elevator and THS can still control, so you still can pitch the aircraft. But when you lose elect, your FAC will not receive any input from here. Pilot will need to move the rudder mechanically. Okay. Right. So no problem. Even though it's a fly-by-wire system, there's a lot of redundancy. Okay. In the worst case scenario, if you lost all computers, can you still control the aircraft?
Yes.
Yes, you still can control the aircraft because there are two areas with the mechanical control. But the catch is you must have hydraulic available. Okay. So can you control pitching up and down? Yeah, using the trim wheel, you still can move the DHS. So the DHS moving up and down, you still can pitch up and down. Okay. Can you still yaw the aircraft? Yep, no problem. You still can control rudder. Rudder still got mechanical cable. As long as you still got hydraulic available, you can move the rudder surface. How do you control rolling? If you lost computer, you cannot control aileron. Are there any cables on the aileron? No. On the wing side, are there cables for those that were on 320 before? No. So spoiler pun tak boleh control. Aileron pun tak boleh control. So can you control rolling in that case? Actually you can, tapi dia indirect lah. Your rolling is done by controlling the rudder. So when you deflect the rudder left and right, your aircraft will yaw. So when you are yawing, one side of the wing is moving faster. What happens to the lift? The lift will increase. So now the aircraft will start rolling indirectly. So they call this induced rolling. But I believe it's very, very hard to control the aircraft. But that is the backup. Okay? So there's one backup only on 2 areas, rudder and THS. Okay. Anyway, we're back to this. Remember the number of computers. I say a lot, but what is important is the number of computers. 2 elect, 3 SAC, 2 FAC. So that is the flight control computers. Unfortunately, when you go to 330 ground handling, the computer will be a number in the regular line. So you need to delete your memory and remember different things after 3 days. But for now, until Friday, it's 2 elect, 3 SAC, 2 FAC. So stack and flap exactly the same. So it's still fly-by-wire, but it's controlled by 2 different computers, only SMCC. So you will still need hydraulic to operate it. So this picture shown here is a mechanical backup. I think nothing much left for our face. So as you can see in this picture, most of the flight control surfaces are the redundancy. Minimum you got 2 hydraulic supply, and minimum you got 2 computers which can control. So I take one example, the left hand aileron. As long as you got blue or green, it's good enough. You just need 1 hydraulic. Normally one actuator is active, the other one is standby or damping mode. Okay. The computers, E1 means normally elect 1 is controlling the blue one, elect 2 controlling the green one. If let's say everything available, who is the boss? So elect 1 controlling the blue one. So if you lost blue hydraulic or elect 1, no problem. You still got another servo available. Okay. So that is the design of it. So aileron, elevator, you got even more than 2 hydraulic, 4 computers in charge. DHS also you got 2 hydraulic and 4 computers in charge. Rudder you got 3 hydraulic, so even more redundancies. Okay. The only surface with a single hydraulic and a single computer is the spoilers. Because spoilers you got so many spoiler surfaces, more than enough. Okay, so you don't need extra redundancies. I mentioned that you need at least one hydraulic to move it in low pitch and going at. Yeah, let's see whether I can lie to you more. Let's say only green hydraulic available. Can you control aileron? Yeah, no problem. What about spoilers? Yeah, 1 and 5 is still available. Can you control elevator? Yeah, at least one side of elevator available. No problem, you can shut it down. EHS still available, but it will be moving at half speed. Okay. Rather obviously available. So no issue. Okay, you can control it. 3 exists. So if you move on to blue and yellow, you will notice the same thing. But without hydraulic, now we need to start praying. Okay. Is it possible without hydraulic? Very unlikely, unless you're in a very bad day, right? And the line doesn't come to that. Or your APU not available, and no choice. I think if you go and find a air crash investigation, but the aircraft landed safely, surprisingly, I think it was Air Transat. It was a 330 with a very similar system. So what happened is the aircraft ran out of fuel. So when you got no fuel, both engine will shut down, APU will not be available. That is when you test the right air turbine. The aircraft managed to become a glider, right, control the flight control, and managed to land the aircraft safely. But the aircraft suffered heavy damage. Okay, so that is a design, actually it works. It's gonna be pretty scary, hopefully you're not in one of those flights. Okay, so next one is flight control loss. So again, this is an Airbus thing. You will not see it on other aircraft, which I know of. Boeing definitely don't have this thing. So what Airbus does, so we need to talk about the design philosophy between Boeing and Airbus. So for Boeing aircraft, the pilot have the last call. The pilot got the ultimate say. Okay? But for Airbus, they don't trust the pilot that much. If the pilot tries to do something funny in flight, like flying the aircraft upside down or trying to stall the aircraft, the computer will just take over the protection when everything is working fine. Okay, so the computer can override unsafe pilot action. When everything is working fine, then it's computer. There are times that we just defect aircraft can still crash. So having this kind of protection, that is done by a computer itself. So I would say it's inside ELAC. Inside ELAC is the strongest computer. So inside you have a software protection, we call it normal law, alternate law, and direct law. So it's just part of the software logic. So I just tell you how it works. In flight, let's say all systems are good, if all computers are working fine, you got all 3 hydraulic, green, blue, and yellow, IDU 1, 2, 3 is okay. So all your A data information is very accurate. So now you will get normal law. Okay. So how does it work is that if you were the pilot, you try to do something funny. Try to push the side stick, pull it to the left. You try to fly the aircraft upside down like a movie flight. Okay? So what happens is that aircraft will start banking, but when it reaches something like 67 degrees going, you still maintain like this, it will stay that way. The flight control surface will not allow any movement anymore. Okay? So maximum you will fly at these positions, you cannot fly upside down. And normal law is working. So if you try to stall an aircraft by pitching too high, so as we pull the side stick up, the aircraft will pitch up. So just before it reaches its stalling angle, it will stop. It will not pitch anymore, even if the gear you just want to pull it up. Okay, so that is Airbus. Basically, you cannot fly upside down. It should be stall free when everything is working fine. That's why there's no stick shaker. Are there any stick shaker on Airbus? Boeing, are there the whole collar shake like crazy? This one there's no, because why? Computer always not have the final say. Okay, there's no stick shaker. So that is how it is. But if let's say you lost one hydraulic, some of the surfaces might not be available, you lost 1 or 2 ADU, your A data is not accurate, you might not be able to calculate the most accurate command. You will go into alternate law. So now you can fly upside down, but your stall protection is still there. Okay, you lost maybe half of the protection. Okay, direct law, there's no protection. You just move, the flight control surface will follow exactly what is your side stick movement. So when aircraft is on ground, it always go into direct law. Because why? Do you need any protection when aircraft is on ground? No. You cannot crash the aircraft. If you manage to crash, let me know. I will Yeah. So you can actually move the flight control surface fully up and down without any protection. But it can also happen in flight if you have a really critical failure. You will go into direct lock. Okay. So pilot will need to be very careful because pilot can stall the aircraft and also crash the aircraft while flying outside. Okay. If you have any issues with this law, there's nothing much you can do. You need to change the configure box. That is the only troubleshooting method that you have. Okay, so remember, direct law only available on ground. Sorry, on ground automatically it will go into direct law. That's why for maintenance crew, we never realize about this thing. On ground, you just follow an exact, but in flight it behaves differently. That is Airbus. Okay. So if you move on to 330, 350, 380, they still have the same concept on the flight control. Okay, so the protection is still part of the software inside the flight control objects. Okay, start and flag system. I will not go into detail. This one is exactly the same thing. Okay, so it's controlled electrically. It's a fly-by-wire system operated hydraulically. So the sled and flag system is quite identical. Just that I will start with the sled system. So the components are very similar also, except for the sled flag portion. So the flag, to control the flag, we got a flag lever. We got a few positions: 0, 1, 2, 3, and 3 down. So when you move the flag lever from 0 to 1, below the flag lever control module, one electrical plug. Okay, so electrical signal go to SFCC, sled and flag control computer. So SFCC is a bit different. There's no active and standby. Both of them active at the same time. Okay. So one SFCC control the left hand side, another one control the right hand side. And also the left and right uses different hydraulic system. Okay. So let's say we start with the sled up. SFCC one controlling the blue hydraulic side. You got a valve block, electrical signal go through. The valve block will just bias automatically, and it will send hydraulic to the correct side of the motor to turn it in the correct direction, and also control the speed. Okay. So when you receive hydraulic, you also have a pressure off brake. When you are hydraulic, it will be released up. So when the motor starts turning, you will start turning in the gearbox. Without hydraulic, the brakes will be on, would prevent any inadvertent or accidental movement. Okay. So that is one side. The other side, SFCC2, is a green hydraulic system. So when everything is good, you got green and blue, you got SFCC1 and 2. The whole thing will be moving at full speed. So the gearbox will just add up these two sides, and from the gearbox, you got all the drive shaft which is connected at one unit. Left and right will be moving at the same speed, exactly the same is connected. Should they be moving differentially, left and right hand, slants or flat? You shouldn't do that because when you do that, the aircraft can lose control because it creates a differential lift on the wings. Okay. So for extra protection, there are sensors. We call it position pickup unit. Okay, PPU. Pickup unit. So this PPU is actually feedback sensors to detect the position. So if let's say the left hand and right hand, this one we call it asymmetry position pickup unit. So if left hand and right hand side you detect it for the different movement, what happens is SFCC will just shut down the whole thing. It will not allow any further movement at all. Because that is not right. Your left hand and right hand side shouldn't be moving differentially. It should be moving together as one unit. So what happens may be part of the drive shaft is broken off. So this part maybe is a free turning. This part is still connected to the gearbox. So it's moving differentially. So before it's too late, it detects a little bit of a differential movement. SFCC will just shut down the system. So for extra protection, SFCC will shut down the protection unit. We call it wingtip brake. So this wingtip brake, once it's energized, you cannot release the wingtip brake anymore. It should stop at the last position until the aircraft lands. You need to do a maintenance troubleshooting. You can only reset from the MCU control. Okay, for extra protection. Okay. So anyway, what's important? Only one part. Is control electrically, move operated hydraulically. Okay, there's no mechanical input, it's purely electrical. Okay, so some interesting part on the slat and flap. Your slat and flap system is not mechanically connected. So you can move the slat only or the flap only without any issue. Okay, so on the flap side it's very similar also. You got two hydraulic. You got SMCC1 on one side, SMCC2 on one side. The whole unit we call it a PCU, power control unit. So when it's moving, you go drive the flap instead of the slat. Okay, so as usual, if you have a differential movement or asymmetry, quick hit brake will just stop it in the last position. Is it possible to move the slat? Let's say your flap or asymmetry condition. The wing tip brake energized and engaged its flight. So your flap basically stuck in the last position. You cannot move anymore throughout the flight. When you operate the flap lever, can your slat still operate in that case? Actually can, no issue, because mechanically it's not connected. So your slat and flap can move on its own, no issue. Okay? Because this is considered highly devices, at least you still got 50% of the operation available. Okay? Even on ground it's the same. If you pull the flap CB, you move the flap lever, only the slats will be moving. Or you pull the slat near CB, when you move the flap lever down, only the flaps will be moving. But you need to be very careful. If someone go and reset the CB, the slat or flap will move accidentally. Okay, following one is the lever position. Okay, let's talk about I think flight control done. That's all. So fuselage. Okay, one small detail only. So as now I think we all know that 318 is the shortest one. But are there any 318 neo? So very nice to know. We just copy from the CO picture notes. So what we have is 319, 320, 321. Okay. So again, now it's quite common to cut production cost down. How do you have the same family but a different variant? Part of the fuselage we come out a few frames, part of the fuselage we cut down a few frames. So when do they do this magic? Is on these two portions. So normally the fuselage, you can, if you cut it like a piece of cake, you got a five different portions. You got a forward fuselage. Okay, the forward fuselage is the cockpit up to door number 1. This is the second portion. This is the center fuselage. This one we call forward. So this one is called in nose. Okay, nose fuselage, forward fuselage, center fuselage. This part until the rear pressure bulkhead, we call it rear fuselage. This portion we call it rear/cone fuselage. So five portions are not equal, 5 different sections. So for Airbus, they have something like a joint venture between different European countries. So these 5 different portions is manufactured by different countries because this aircraft is certified by EASA. Okay. So normally the nose and center fuselage is done by France. The rest should be done by Germany. Okay. So that's why, have you seen paint stripping of the aircraft before? We have done painting. On Boeing, you will see the primer is the same color, but most of the time the Boeing primer will be off. You will see a naked shiny fuselage. Airbus painted primer macam the here is a bit hard to scrub off. You will notice the pilot different color or different sections. Because why? It's manufactured by different countries. So even though it's the same spec, the primer and colors are different. So that's the reason. So how do they patch up everything? They need to send to a hangar called a place called final assembly line. So these different sections ship together, maybe pakai beluga punya aircraft, okay, ship there, and then at the same production line, they connect everything into pieces, okay, in the production punya hangar. Okay. So I'm talking a bit too much now. Anyway, what is the difference? For the same production line, you can assemble 319, 320, 321. So how do you do that? You just swap these 2 sections away. Okay? If you want to make it into 320, these 2 portions you pakai yang panjang skipping, you cantum, and this one is a 320. If you want it to make it into a 321, you add 2 more extra sections. One over here, we call it section 14A, 16A, patch together. Now it becomes a 321. Okay. So what you need to do, you use the same line, but you're going to adjust docking, just like what we do like. Okay. So So yeah, that one will cut down the cost a lot. So the main difference on the freestyle flight. So now you put in more seats, yeah, you can change it into a 321 using the same one. So 321 got how many extra sections? That is the main important information. Okay, you got two. So 321 you got extra 8 frames on the forward end, extra 5 frames at the back. So what you do, you tambah 8 frames over here, you tambah 5 frames over here. We call it section 14A and 16A. Then you patch it together. Okay. So just highlight, I think on 321, just circle 14A, 16A. Got 2 extra sections. Okay. If you cut down the frames of these 2 portions, it becomes a 390. You cut down even further, it becomes shorter. So it becomes a 380. Okay. So all these are nice to know up. All these are nice. For fuselage premium Airbus coding, we start with 11 up to section 90. So if you see it start with 1 up, and 1 is the fuselage related premium section. Okay, since we have this picture here, let's talk about the doors. On 320, how many passenger doors do we have? 4, right? We have 2 on the forward, 2 on the outside. How many overwing doors? 4 also, 2 on the left and 2 on the right. That is so 319 is similar, okay? 4 doors. But the overwing doors, it depends. If you want to carry less passenger, you just put 1 overwing door. If you want to maximize the passenger number, you can also put in 2 doors. Okay, but for 318, only 1 door forward and aft. Because it's so short, it's possible to put in 2 overwing doors. Only 1. Anyway, we don't have any 318 new. So let's talk about 321. So 321 is a bit special. Standard 321 have no overwing doors. But what we have is 8 full-size passenger doors. So number door 2 and number door 3, we call it 1, 2, 3, and 4. Number door 2 and 3 operates the same way like a forward and aft passenger door. Just that the slide is installed outside, like the off-wing escape slide, below the door level. Okay, so if you arm the door, you operate the door up, you can deploy the slide, but the slide is not attached to the door lower area, they can't go up. Okay, but the operation just same like the passenger door. Okay, so a standard 321 seal on your aircraft, there's no overwing doors. Okay. But what we have, the 321 neo, anyone work on the 321 neo on our aircraft before? Asia fleet. Or you haven't had a chance to see it. Our 321 is a bit special. They panggil A321 Airbus Cabin Tax. ACF, the short form is ACF. So I think it started in 2018 macam tu lah. So kalau you order 321 saja after 2018 you will not get this 8-door version. Okay, so what you will get is door number 1 is still there. Number 2 dia dah remove to put in more passenger seats. Number 3 is still there tapi dia gerak belakang sikit lah. Number 4 is still there. So what you have is door 1, 3 and 4 minus door number 2. They add on 2 overwing doors on the 321. Okay, so the configuration, which is different from what we see here on the ACF, is 6 passenger door plus 4 overwing doors. Okay. But the overwing doors have a slightly different design. Dia macam 737. Dia tak boleh cabut, dia hinge on top macam cargo door. Okay, but the operation is similar, so you open outwards. Okay, it's still an overwing door. So why do they have this kind of weird design? Anyway, there's no exam since you're working on the 321 neo. Is to become a sardine can. Okay. You remove door number 2. Now you can put in extra 1 or 2 rows of seats, correct? If you have overwing doors, you still can put in seats. Tapi dia pitching dia extend sikit lah, but you still can squeeze in passenger. And also on the neo config, if you have worked on the 320 neo and the 320 SEO in our fleet, you will notice that the aft lavatory position macam lain sikit. On the 320, the older version, up lavatory is forward of the up door. But what on the new aircraft did is that these two lavatory dia gerak kat belakang. So your galley become half size, the other half your galley jadi lavatory, jadi lagi sempit. But what is the benefit of doing that? You can put in another 6 passengers to increase the pax count. Okay, so by doing this flexible arrangement, that's why panggil Airbus cabin flex. The standard 321 previously maximum is 220 lah. Now you extend up to 244 maximum. So extra revenue lah, 24 passengers. So Uncle Tony very happy lah. Extra bonus for you guys lah. But for our config, I think it's 236 lah. That is the Asia config lah. The main idea is to squeeze in more passengers. So anyway, just extra information. What is important is few star section, 321 we got extra 2 sections. It's quite a lot. That's why a lot of airlines they start to change wide body into narrow body, because when you can put in 240 passengers, then they are very close to wide body in your aircraft, and it's much easier to fill up the passenger number. Okay. Some more with the new merely 1.8 engine, you can fly a bit further. That also make your route a bit more easier for training. Okay, composite application, there's no difference, it's the same. I think you have covered this, you have composite application. Where can you find quartz fiber reinforced plastic? Radom uses a special type of fiberglass. They panggil quartz fiber, QFRP. Okay. So only on the radome. Most of the flight control surfaces, the fan cowl, reversal cowl, the floorboard, okay. Even your THS and your vertical feet with the rudder and the elevator uses CFRP, it's a fiberglass. Are you aware of that? Your DHS is fiberglass on the whole thing. Yeah. And also your vertical feet, not the rudder, the whole feet is actually fiberglass. Are you aware of that? No. Well, actually, your fiberglass are the 2 types. I think the composite people can tell me more. CFRP, you got 2 types. Satu panggil sandwich. Okay, I think sandwich, you guys are quite familiar. Sandwich, you have the outer skin and upper or lower skin or outer or inner skin. Then you bond it together with the honeycomb. Okay, so how do you form this skin? Is that you got layers of a fiberglass cloth. Normally the orientation is 90 degrees, put it like this. Then you apply resin, which is a glue. Then you apply pressure and heat. After it cures, it becomes a very strong and a solid material. And to save the weight, upper and lower skin, you just bond it together with the honeycomb structure. Okay, so the honeycomb structure also gives it strength. But now it becomes very lightweight. The strength is equivalent like the metallic structure. Okay, so for aircraft, this is ideal. You want to achieve lightweight to safety. Okay. So there's another type of composite. It's monolithic. Monolithic is this portion here. So you apply layers of a fiberglass cloth, it's not fiberglass like carbon fiber cloth. You can put it into a special mold and then you form it into a complex shape. Okay? So it can become something like a rear spar, upper skin with the integrated stringers. Tapi the mold besar gila and you need to apply a special technique. Okay? And minus honeycomb, there's no honeycomb. So it's a solid CFRP structure. So where can you find this monolithic design? Is on the DHS and the vertical feet. Okay. So what is so pros we all know is lightweight and strong, right? The carbon fiber. But what is the problem with the composite? Maybe you have seen damage before, right? Composite. So it's not that good for impact damage. If you have an impact damage, most of the time you can see the composite crack through, you can see the crush being honeycomb, and you need to call our composite friend and do a proper repair. Okay. But for monolithic composite also have the same problem. Okay, so it might crack through. But the composite is very flexible. Sometimes if you have an impact damage, it might bounce back to original shape. So from outside looks like it's okay, but internally it's crushed already. Okay, so you might need to call NDT to inspect which area is damaged. So for sandwich type of composite, how do you know that there's damage? How do you know macam ada disbond ke ada delamination? You need to use money lah. Jadi pakai coin test. Nowadays you pakai e-wallet, I'm not sure where you get it. So you pakai coin test. That one is simple mere method lah. The more accurate one is panggil NDT. You can use an ultrasonic or thermography to detect which area that was. So this area you can avoid repair. Contact test will not work on the monolithic because they macam metal. It's the same sound. So you will not have that hollow bouncing sound like this one. So you need to call NDT for inspection. Okay. So why do I tell you this? Because if you are not aware of the DHS and vertical fin, that area also got a lot of maintenance action. Right? If you drop the tooling, when you are working on the rudder, the tooling or component drop on top of the DHS with such height, definitely there will be some damage, right? But you might see that hey, it's okay, because it bounced back to original shape. So don't leave it as it is. You should immediately go and mark it. You should tell your LAE, NDT should come over to do a proper inspection. Okay, because this area is actually composite. Same goes to the vertical fin. So be very gentle to it. Don't use a hammer to knock it out, definitely you will damage the system. Right? Actually, there's nothing important here. Nice to know. Okay. I think by now you know how to open the passenger door, right? Yeah. So, can you open from inside? Obviously, right? So this lever, you just move it up. So when you move it up, what happens is that the door will start to lift up a little bit, and you can push it all the way forward until you lock it in open position. So you can also open from outside. You also have an outer handle, which does a similar thing. To close it, you press on the gas lock, and you can move it back to the frame. Over down. It's like that, very, very straightforward. Okay. What happens when you arm this yellow lever? You put it in arm position and you open the door. What will happen? The slide will be deployed. So actually, two things could happen. The door inside here, there's one emergency cylinder. It's armed emergency. So when you move it up, the cylinder punya nitrogen bottle will get punctured. It will push the door automatically open. So at the same time, you have a slide over here with the gun bar. So when you arm this lever, the gun bar is fitted to the floor structure. Okay, on the gun bar fitting. So when the door opens up, from this package, the slide will just drop, and by its own weight, it will start to move on. And the slide will be attached to the floor structure. Okay, so two things will happen. What happens if you arm the door and someone opens from outside? For safety, automatically this will spring back to this arm because of mechanical control inside. For safety, okay, because if we don't want our friend open the door from outside, it's inside the door. Okay, it's very, very dangerous. So yeah, okay, highlight this part. If you open the door from outside, it will disarm the escape slide automatically. How do you know that the slide is armed when you open the door? Two colors, right? One is red, one is white color. So if you see the white color light flashing, sorry, not flashing, it will come on steady. So be very careful, the slide might be armed. Okay. But if you continue open from outside, if everything is good, it will spring back to this arm position. So if you open the door from outside, you see, so my maintenance practice is like this, for safety. Open from inside, definitely you can check with you. If you arm it and open from inside, you need to prepare your resume. So normally you can check, masukkan safety key, make sure it always stays in this arm position. But open from outside can be tricky. If you forgot to disarm this, you leave the outer handle up. So you lift up a little bit, you stay in the room, you take out the white color light come on. If the white color light comes on, do not continue with open A, even though the book tells you it will automatically disarm. It might not disarm properly. It's like I deploy with you on the high lift, things can happen. Okay, so you lower it down, get inside the aircraft, disarm from here, and you double check dia punya gerbang ada disarm betul-betul ke tak. Okay, then only you open the door. Okay, because why I tell you this, especially you guys working in the hangar, sometimes you have a lot of components, you might remove the door, you might need to do a full rigging. If the rigging wasn't done right, it might not disarm properly. Okay, so never trust your friend too much. Sometimes because of wear and tear, it might not disarm properly also. Another problem is icing. If let's say you fly to a very cold region, once the aircraft landed, maybe the ice is still on the good bar meeting. The good bar might get stuck onto the door structure. Okay, it might not get back to the door. So if you open up, the slide can still move on. Okay, Okay, what about overwing doors? How do you arm the overwing doors? From inside, right? You open up this cover here, the other dual pin. Okay, dual arming lever. One pointing this way, one pointing this way. So if it's extended, it's in arm position. So you can also disarm it. So disarming the overwing door, how do you do that? From the same access can you do it from inside kan? If you arm the overwing door, you forgot to disarm. You can also open the overwing door from outside. There's a two factor. So you can push it open. What happens to the overwing escape slide? It will deploy. So for overwing doors, you need to be careful. There's no auto disarming if you open from outside. Because why? This thing always happens in the hangar. I think SAE happened before. You forgot to disarm and you're on top of the wing and you got a shortcut there. You just open it. The next thing you see, overwing escape slide deploy. Because overwing doors, there's no automatic disarming. So that is the difference. Passenger door, yes, you open from outside, there's no auto disarm. Overwing doors, you can only arm and disarm from inside the cabin. Okay, very, very important. So highlight this part. So not only for an exam, this one for maintenance. Now you need to get ready a resume. So deploy in the hangar can be quite dangerous, right? All the things on and people. Okay, cargo door, I think you guys know already. So which hydraulic system?
Yellow.
Okay, so if you have electrical power, everything is working fine. You just have to here. You have a control panel over here on the next few slides. You just select to open and close. Which pump will normally run on the yellow system? The electric pump will start running and automatically. So let's say electric pump not available, the next option is your yellow cargo door hand pump on your yellow hydraulic service panel. So the handle is on the yellow hydraulic service panel. Yeah, highlight this part. Okay. So you can use yellow electric pump or nano hand pump on the forward and up cargo. But for manual operation, you need two personnel, one to operate the receiver and another one. What about what cargo door? Which hydraulic system? Ada hydraulic system dia pakai spring bungee on top. So it's just a mechanical one. You just push it inwards, it will automatically go up. If it's still in good shape. So for butt cargo door, actually only available for 320 and 321. Because 318 and 319 is so short. You don't need a butt cargo. But can you still access the butt cargo area? Yeah, butt cargo door, you just go in, you can access the same area. That's why I mentioned there 320, 321. So 318, the door is slimmer, operation is the same because of the fuselage restriction of the size. Anyway, we don't have any 318 new. Avionics compartment door, how many of them? Four. Why a narrow body aircraft needs 4 avionics door? Normally a wide body, satu saja kan, 330 got one door only. Yeah. Because of the excess lah. If you have gone inside you cannot run inside lah. Kita punya avionics compartment. So this is the nose landing gear wheel well. Your avionics compartment is surrounding the nose landing gear wheel well. So to access different areas, that's why you need extra doors now. So we have a forward section, left hand, right hand, and the up one on the right. So if you open up, there's a very nice robot for you to stand on top. So there are 2 areas that you can stand inside is the forward one and the up one. The left hand and right hand only half of your body can go in. Okay. So for 320, we also have some layman terms of different areas. So normally the forward one is just mark your forward compartment, forward avionics, up avionics on the up one. The left one we call it oxygen compartment, oxygen bay, because of the oxygen bottle. Right hand side is the battery compartment, because we got battery 1 and 2, one in front of you, one up. Anyway, it literally is the same compartment, it's an avionics compartment. Okay, so remember the number of doors, we got total of 4. So you can open from outside, take 2 fancy. Okay. Pop the square, this handle will pop out, and you just select open, push it in. Okay, time's up for lunch break, so let's go for a nice lunch and see you all at 1 o'clock. Is that okay? So far, any questions? Yeah, right, so let's see you everyone.
Good morning.
Any questions on the training that we have covered? There's a part lagi, we got 1.5 hours. Any issues on the systems? Are there anything that you can understand or you want to know more? Yeah.
Kalau untuk reaktif kan ICU. So SMLA dia punya
actually kalau you nak, it depends on what kind of deactivation. If you want to deactivate for flight under MEL condition, you just want to deactivate the system. ICU you put to inhibit, you use the same pin and masukkan the pin and to just follow the red color. These 2 things are the other one is for flight. Maintenance, you pun kena letak ICU to inhibit, tapi you use the one with the streamer. The one is on the hydraulic side. So mechanical side, you just tarik the yellow lever on the SMLA.
Oh, so dua kena reaktif lah.
That one is the best safety lah. So as long as you tarik, you stay at 45 degrees even if you got hydraulic, the thing suddenly activated, you would just jam on the whole.
So kalau macam kita activate ICU dia yang SMLA tu tak
Actually tak cukup lah.
Okay lah.
Tapi SMLA dia senang lah. Deactivate lah, just tarik saja. So no harm.
So SMLA ada macam dia untuk dalam tutup park.
Ya betul. Kalau untuk fan kau ada satu metallic bracket tolak balik lah, normalize. Because sometimes hard to tell even though you deactivate ICU your friend got the other side of the reverser kau maybe dia start turning. Dia tak perasan lah. So tapi kalau tarik SMLA punya yellow handle you try to turn nanti boleh. Because mechanically dia dah jam.
Oh, so tak boleh nak buka handle ni
Okay lah. So kalau let's say you buka halfway you tarik 45 degrees, dia akan start ke sana.
Oh.
Dia will reset. You kena reset baru boleh turn. Just remember SMLA lah, yellow pencil. Any other questions? Okay. Right, so already for a recap. So this is also like a closing lah. Go for examination. So we have covered quite a lot, almost like 200 over pages today's. So we start with the aircraft general information. Okay, so on the water service panel, on the 320, berapa water drain panel? Two lah, 321.
One.
Okay, so where is the water tank location on the 320?
Center.
Which is on the outside of the forward cargo lah. Near to the mixer unit lah, just in front. Where is the water tank for 321? Cargo. Okay, where are the main jack points of our 320 family? One of the engine and on the forward nose area. Okay. Do you need to install adapters?
Yes.
Are the adapters interchangeable between 320 and
No.
So that one you need to remember. Okay. But some engineers will be able to force it in. Every time you need to involve a machine shop. Because this incident also happened in Toulouse, including Airbus. So it's a very easy to make mistake. Okay, how do you check leveling? What is the norm? What is the easiest way? AIDS, but you need to align ADU with the electrical power available. If AIDS not available, what is the next option? So the third one is not that common. It's the NEQ monitor, which is not available. Okay, airbag system. Engine number one, the EDP is which hydraulic? Green. What about number two?
Yellow.
What is the normal pump for blue system?
Electric.
Electric pump. Ram air turbine connected to which hydraulic system?
Blue.
PTU connected to which hydraulic system?
Yellow.
Fire shuttle valve connected to which kind of pumps? Fire shuttle valve. EDP, yeah. So fire shuttle valve isolates hydraulic, fire shuttle valve isolates hydraulic to the engine side of the EDP. Okay. So on the electrical pump, we don't have any fire shuttle valve. Ram air turbine doesn't have any. How do you reset back the ram air turbine? How do you stow back a ram air turbine? Can you do it in flight? No. That one is a one-way ticket. You can extend in flight, but to stow it back, you need to do it on ground. Because you need to access from the blue hydraulic service bank. You cannot do that in flight. IU1 and 2 switch over. You select to up or select to down? Up
Linear.
selection. Every time you select to up, you just switch over. So that is the logic. Alternate extension, what kind of design it is? How do you operate alternate extension? Gravity. So what is the design? Is it electrical switch? Mechanical extension. Okay, which computer in charge of normal braking? Which computer calculates anti-skid? PSU also. So for normal braking to be available, which hydraulic is required? Green. So alternate braking uses which hydraulic? Yellow. Okay, which computer in charge of alternate braking? PCU. But do you have anti-skid protection under alternate braking? You might have it depending on your PSU. So your PSU will calculate the anti-skid control. It will tell ABCU what to do. Okay, anti-skid order will come from PSU. So trickle pressure indicator shows you which hydraulic. So it shows you which kind of brake system. Yellow one, which is alternate and parking brake. So these two systems using yellow. How do you control steering? How many ways can you control steering?
74.
Oh, that one is the decrease, right? And two ways lah. So you got the leader. If you want to have a full deflection, they want to advance already. I'm also type training. Anyway, if you want to have a full deflection, which one do you use? Steering handle or steering lever. Okay, so can you do steering using the rudder pedals?
Yes.
6 degrees only lah. Okay, rolling control by which flight control surfaces? Roll movement. What about spoilers? Are spoilers involved? Yes. So it can be a combination of aileron plus spoilers. In the backup mode, spoilers alone can also control rolling. Okay. Any different in design on the flap of a 321?
Double slotter.
Double slotter. But on the hydraulic side, the components is exactly the same. Only the flap physical design is different. Okay, what are the computers available for flight control system? What are the main computers?
Elect.
How many elect do we have? 2. Elect. How many SAC?
3.
Okay. What about FAC? 2. So total of 7 computers. Where can you find mechanical backup? 2 areas only, right? Mechanical backup. One is on the rudder, the other one is on the trim wheel. So rolling is done by rudder. On ground, what kind of law will you get? Red law. Okay, so on ground, you will not crash the aircraft, so no protection required. So in fact, you cannot see the demonstration of normal and alternate law on ground. So that's why even if you ask LAE how it works, actually no one can tell you. On ground is always done. Okay, are there any mechanical cable on the flap and slat system?
No.
That's not mechanical cable. So it's in control electrically operated hydraulic. Okay, so if you got both SFCC and 2 hydraulic for slat or flat, you will get a full speed up. If you lost half of it, you will go into half speed. Okay, you still get into surface. Okay, fuselage 321 compared to 320. How many extra sections?
8 forward.
2 sections. Fuselage sections is 2. But the total frame is 8 plus 5, 13 frames. Read the question very carefully. It is not 8 extra sections. 2 sections. So how do you identify you have 14A, 16A? So the extra A is extra sections. Along Malaysia, you might find 13A. Okay, just be careful for maintaining maintenance, the whole THS and the vertical step is actually CFRP. It's a bit fragile, even though it looks and feels like a solid metal. Can you open the passenger door from inside and outside? And what happens if you arm the passenger door and you open from outside? Because it bring back to this arm, okay, for safety. Okay, what about overwing doors? If you open from outside, will you disarm the door? No. You will deploy the off-wing escape slide. So the only way for you to disarm and arm it is from inside. Okay. So remember by part up. So our 321 also got overwing doors in the same design. Cargo door. Forward aft cargo door uses which hydraulic system? So normally which pump will be used? Electric pump. Electric pump are available. Hand pump. How many avionics door? 4. Okay, so you got 2 colors. So you got 2 warning lights. What is the meaning of the red color one? What about the white color? Will these 2 lights come on at the same time? No. So what kind of logic does it follow? It's this arming lever, right? So if you disarm the lever and you got residual pressure, which light will come on? So if you arm the lever, you try to open the door, which light will come on? So remember that, the arming lever being logic. So if you see any of this light, just be careful, you should lower down the handle, try to normalize it and try to open from inside. Okay. Double check that the good bar has been deactivated properly. Okay, so how do you know that the cargo door is properly latched and locked? So normally you can check from the door page, but to double check physically, you can pakai the remarking. So if you go with base maintenance, please make sure that the lens is, if you cannot see, chala the road, just order a new one and replace it. Sometimes it can be a bit hard to polish back. But normally line maintenance we don't care. Any special function for this lower side wall panel or down? Decompression protection in both directions. Panel. I think Boeing also called the same thing. What kind of crew oxygen system do we use? Water. Yes, it's type. It's almost so where can you find the oxygen cylinder? Inside of avionics compartment. So any difference, any possible configuration differences on the new aircraft? Okay, you might have a duplicate system, so you just double up everything. But now instead of a single bottom connected to 3 or 4 crews, one bottom connected to the other side connected to the other. What kind of oxygen do we use on the passenger oxygen system? And what altitude will it drop down automatically? What can be altitude? Not 4,000, it's 40,000 feet. 4,000 you don't need oxygen. So for human, normally up to 11 or 12,000 should be still okay. Provided you have any medical issues. 40,000 feet level you need oxygen. If not, you will suffer anoxia and hypoxia. Okay, can you deploy it manually? Yes. If some of the door got stuck, how do you open it? Manually. Panel we have covered. Any special function, any other name for this green bar? Air stop bar. So what is the function of air stop bar?
One way.
One way you prevent having air leakage to maintain the cabin. So if you got no liquid, it will just close. But again, it's a common problem. Certain slides sometimes you don't really don't know. Maybe it's the first time I come out, or the rubbish and all, they just throw it in. It might not stop. That's quite a common problem. Okay, toilet system controlled by which computer? Seats. Okay, so remember, inside seats also got a software like the SCF and the SDF. So you reduce 2 boxes already, reduce production cost also. Okay, the MC1 powers up which display unit? The MC1. Captain APs and also ECAM, so that is a layout on the 320. Okay, ECAM is coming from the MC1, graphic card computer. What's the function of a CFDIU? Memorize calls and also carry out byte tests, initiate byte tests. So when you're making selection from the MCU, actually you are talking to CFDIU. The internal memory has is more on the CFDIU because most of the avionics computer, maybe you can store like one flight. Some doesn't even have an internal memory. So any fault you can store on CFDIU. So be very careful if you're B2, jangan kacau CFDIU. If you go and rewrite the CFDIU, you might zero back everything. You might lose all your information. Where can you find AIDS? Which part of an FDIU? EMU. So data management unit can process most of the signals out of the aircraft. So AIDS is hosted inside data management unit. Okay. So the other half is related to the black box. Okay. AC bus 1. Sorry. AC essential bus and DC essential bus normally tap from which side? Always bus 1. Always from bus 1. If it fails, we tap from bus 2. CSMG tap which hydraulic system for operation? Emergency generator or CSMG? Blue. It's tied together with your ram and the bus. Okay. Diru 1 powers up which side? What about 2? Echo. Number 3? Standby. Instrument landing system falls under which category? Landing aids. Okay. What about GPS? Dependent position determining system because you depend on external satellites. So for it to work, you need to capture at least signal from 4 satellites. So it's not an advanced tech, like even your phone can do that nowadays. Okay, normal tuning for this navigation frequencies is done by which computer? Normal tuning. FFPC, because your flight plan is inside. Okay, as you fly along the flight plan, any surrounding navigation stations you can capture this automatically tune it. Okay, so in case normal tuning fails, you can do manual tuning from the MCDU. You can also use the hard. Okay, so we have an FNGC. Autopilot, flight director, and auto thrust falls under which portion? Management or guidance? So you got management part, which is the flight plan, lateral and vertical. The guidance part is where you can find FD, autopilot, and auto thrust. So auto thrust comes from FNGC. But the signal, if you not reach FedEx directly, you will go through an interface computer. What is the name of the interface computer? Flight envelope protection protection calculated by which computer? FAC. So FAC got two main functions. One of it is related to the rudder autopilot control, A327. The other half is the flight attendant protection. Cabin lighting controlled by which computer? CIDS. What will happen if you lost both CIDS director 1 and 2? Will the cabin be totally dark? No, F2 is related to emergency lighting. But what about the rest of the lighting? The lavatory lights, the cabin lights, CD reading lights. So as a fail-safe feature, if you lost both seats, director 1 and 2, everything will be light up to 100%. Okay, so you lost the control, but all lighting will go to 100%. So if you see the cabin become like 100% light up, you double check on the seats. Maybe seats in the CD that are failing, or maybe there's some issue. Okay, F2. Backup battery for emergency. Okay, on a new aircraft, what is the design on the center tank side? Do you have any center tank pump? No. So what is the combination? Transfer pump and jet pump. So you got two sets up. Okay. How many fuel pumps do we have? Two per wing. So we got to make a lot more. So there's no center tank pump. So on a SEAL aircraft, you will see 6 fuel pump. Okay. On the fire protection system, CFM 1A engine got how many fire detectors? Four sets of fire detectors. How do you arm the script? When will the white color script light come on? How do you arm it? You need to release the fire switch. If you don't release the fire switch, you press on the script, actually the bottle will not get fired up. Okay. So the logic is something like a moving aircraft. You need to pull the fire handle, then will you arm it, then you turn it to discharge the bottle. The same logic, but with different design. Where is this fire panel? Is it on the center pedestal or overhead? Overhead. Airbus is always on the overhead panel. Okay, avionics smoke is monitored by which computer? So it's AVC, avionics equipment ventilation controller. Where can you find the smoke detector? Is it on the supply line or the exhaust line? Exhaust line. On ground is open loop or closed loop? Open. On ground is always open. But sometimes you might find the ground operation, both inlet and outlet will go to close. Raining, you need to close manually. You go to override. But sometimes there are some updated logic on the AEBC. Anyway, it's not part of the exam, so just ignore for the exam. But in real life, sometimes you might find both doors go to close. Because your AEBC got two logic. The updated logic is that when your outside temperature is higher than, I can't remember what's the exact temperature, let's say more than 30 degrees, it will go to close. So it follows the outside air temperature. Because according to Airbus, at high temperature, you might get high humidity. So you might damage the computer in the long run. So no issue, it can be open or closed. If you go to the cockpit, you don't see any message, it's still working fine. Okay. Anyway, just ignore that. In the system tell you it's open. Cargo smoke detection. Cargo smoke done by monitored by which computer? CIDS. So another part-time job of CIDS. What about lavatory smoke? Same thing also, CIDS. Okay, at high altitude, will you get both electrical power and pneumatic supply? So you get electrical
Electrical.
So APU got how many shafts?
One.
One shaft only. So I think currently all our aircraft for seal and neo is a Honeywell 1319A. Okay, LEAP-1A can be installed on which aircraft?
319,
319, 320, and 321. Okay, so 318, there's no 318 new lah. You will not be able to find. Okay, reversal cow got how many latches? 8. What about fan cow? 3. So the mechanical flag is connected to which latch of the fan cow?
First.
1. So what is the sequence to open fan cow?
1, 2.
Okay. So to close that's really 1. So the mechanical flag is the first to open and the last one is to open. Okay, latch number 1, we have a mechanical flag. What type of reversal do we use? Is there a problem? No. Translating sleeve. Okay, so we use this translating sleeve type of reversal. What is the bypass ratio for LEAP-1A? 1. What is the material of the fan blade? Fibers, yeah, right. If you see damage, you can see the internal CFRP exposure. If you got the damage, you see any signs of a first strike, but the blade looks okay. Don't trust the blade too much. You should call NDT to come. Because why? Carbon fiber is very flexible. So even though it sustains effect damage, it crushed internally, it might bounce back to original shape. It usually happen on one of our aircraft with first strike. LE remove the fan blade. You can actually bend it using your hand. It looks totally fine for outside. Okay, so if you see any signs of FAE or you suspect there's a first strike, inform an LE, you should go ahead and inform NDT to a proper inspection. One thing good about carbon fiber blade is that you don't need to do fan blade loop. It's a carbon fiber. If a titanium blade, you need to do fan blade loop. If not, you might suffer high vibration. Okay. One of the common defects, which you can see, is that the cone when your paint wasn't that good. After some time, the paint, you don't see any paint anymore. Okay, where is the fuel filter location? Left side, so it's on the bottom, not on the right. Okay, what is the fuel metering component? Which component controls fuel metering? FMU. So it's very straightforward, FMU. But CFM 56, we call it HMU. Some engine can get FCU, fuel control unit. Where is the oil tank location?
Right hand.
Right hand side. Okay, what are the computers under FedEx? EAC and also credit subsystem. So you got 2 EAC and a PSS subsystem. So the design is also different. On the CFM 56 is one huge computer, ECU in the whole thing. So this one you got 3 separate computers on the right hand side. So the top one is ECA, E, and the bottom one is a pressure transistor with a pneumatic connection. I believe it's because of the size, because of the curvature. I cannot design a very big computer which is with a very big curve, so speed. Okay, to deactivate hydraulically on the reverser, which component?
ICU.
ICU, so you go to ICU. So the lever is on the ICU, access is from the left hand side of the fan cowl. Okay, do you need to close the fan cowl before you deploy the slats?
Yes.
So the fan cowl might keep the slat as well. I think your fan cowl can open in two positions. That one should be the maximum opening. Maybe during engine removal, I think the open maximum. That one maybe you can understand. Just be careful. Pneumatics. Okay. ACSC control which component on the back to maintain the temperature? Ram air inlet flap, that is the inlet flap or inlet door, ram air inlet door. And what is the other component? Bypass valve. So there's no ram air outlet flap or anything under the exhaust, it's just a fins. On the 330, you will see ram air inlet door and outlet door. A bit more precise, but open circuit on ground will be like we have covered. In flight, will be closed circuit. Where will you get this intermediate config? Smoke, you need to select. How many safety valves do we have? What kind of differential pressure does it provide? Positive and negative. Which component separates oxygen, enriched air, and nitrogen? IGGS, but the filter we call it as a filter module. So it falls under IGGS. So it looks like something like a black cylinder, so with no moving parts. So as you push the pressurized air over, it will just separate using this small material. Okay, for wing anti-icing, how many push buttons? Are there any automatic operation? No. So all anti-icing, you need to turn on and off. Wing anti-icing. How many nacelle anti-ice valve on the neo aircraft per engine? Two. Engine anti-ice valve, we got two. Any special name for this engine anti-ice valve? PRSOV, pressure regulating internal valve. So fan cowl opening sequence, you know already. How do you know that the whole open rod is secured in open position? Green indication, so you see a green band, this means that it's safe. If you see red color or you don't see any color at all, depending on the config, it's not safe, it might drop accidentally. So be very careful, especially on the reverser cowl, that's very heavy. You want to try it, something nasty can happen. The ICU, that's where you can do exhibition. 8 lectures on the reverser cowl, make sure you count because this screw you might miss out at the back. It's on the cross section. So where is this yellow locking handle? SMLA. So this is the safest stuff. If you pull it to 45 degrees, and your reverser would never move at all. You mechanically jam up the whole thing. So it's more for maintenance. Oil servicing panel, that panel right hand side. starter aircraft. Do you need to use any tooling? It is the frigate drive. So starter aircraft on the left or right? Left. Right. 56 is on the right hand side, but you need a tooling, you have a handle. On the aircraft itself, you got a handle. Okay, that's all for our session. Any questions? Good, right. So again, exam will be 10:30, but I think we get ready around 10:10 at this classroom. Okay. So when ready, we can go to the exam. 20 questions, again 75% passing mark, we got up to 3 attempts.